Alright, so now it is... Okay, it's working. It's working. Alright. Hard drive spins down when it's not being used, which creates tons of trouble for me. Yeah, don't buy an eco-friendly hard drive. It just wears more from stopping spinning, starting spinning all the fucking time. I had to write a little bash script to keep it spinning by, like, writing to the disk, like, every minute. But, you know, sometimes I forget to keep that script open, right? Because I have to actually have that script open, like, 24/7 for everything to work properly. Okay, let's actually look at this. Done ranting. So, we're still on sprint number 3, Taudepo, which is the texture as uniform depot. I just added another item, inserted another item, number 5, right? So this list will look different from the previous video. Number 5, keybind, centralized keyboard bindings. So, if every editor is gonna have keys that can be pressed and do things, we need a centralized place to locate all of those bindings. Otherwise, it's going to be like this spaghetti code mess where, like, you have to dig into the frag bed to see the frag bed's keyboard bindings. You got to dig into the Paint 5D files to see what their bindings are, and you got to dig into, like, all these different files individually to see what their bindings are, right? Alternatively, we could just put all the bindings up front on the top level of the main function file, right? Our main file that kind of controls the main loop of the game. However, then we're going to get, like, really bloated in that main file, and I'd rather not get that bloated. So we want to kind of continue with the, you know, flat is better than nested idea, but we also want to make sure that our main file is a centralized repository for... want to make sure our main file just consolidates the overall logic. We don't want too many nitty-gritty details in our main function file, our f._. file. So if we had a file that's just a list of all the keyboard bindings for the different subsystems, then we have a nice piece of reference where we can see what does what, right? We can just reference that and look at it and easily control what happens, right? If we need to change things around. So we're going to stub that in. That's the first thing we're going to do. Actually, before we stub it in, we're going to write it because I have some ideas fresh in my mind of how that needs to work. So before we go through the tedious work of stubbing it in, we need to actually just write that code. So let's get to it. So let's switch screens to the bottom, and let's actually open up our editors. So don't worry about this. This is just me stalking people on the internet, Twitch people. Don't look at that, or look at it. I don't know. So let's just really quick. Let's open up. It doesn't really matter what file we open up. Oh yeah. So this might be a little bit. Let's just open up two things. Split our screens. So we got two different editors, and then we can close this. Let's open up our main library file, or our main our main C file. Keep that there for reference. And over here on this screen, let's just start writing out, or actually no, let's keep with data on this side, functions on this side. So let's actually write out what we need. So we need something like, so this will be KEYBIND.D. _, and we need something like struct AAC 2020 keybind public library struct, right? So we're gonna just keep it nice and verbose because we're not gonna reference this type anywhere else, so we can be as verbose as we want. And we'll make a instance of it right here. So we'll call it AAC 2020 keybind. And then we'll initialize it, right? And so then the initializer list will be here. And then we'll figure out what goes in here. So we're actually going to, we are going to do a little bit of nesting here. I know that flat is better than nested, but it's not going to be hard to remember what the different categories are, because we're going to name each category of key bindings based on the system that it is associated with. Okay, so not all systems have key bindings, right? So we could do struct AAC 2020 keybind, and we could do keybind, and then Taudepo, and we're just gonna make this empty. And call it Tau. Do you want to call it Taudepo, like that, lowercase, or do you want to call it uppercase? Actually, we should probably do uppercase, just because uppercase is going to be this is already public, and most of our namespaces are all capitals, so it would just be easier to get to. Also, I guess, you know, capitals is public, lowercases is private, so we should probably keep that pattern as well. So Taudepo, and yeah, and we just need the instance here like that. And this is actually going to have no members, only sub-editors get key bindings. Okay, so we just want to explicitly kind of say why we don't do what we do. So KEYBIND.D._. So we're going to call it KEYBIND.D._. And then we can do struct AAC 2020 keybind, and then paint 5D. And so you notice that this has like paint 5D. It has extra it has kind of like, this is extra redundancy. We might actually want to associate these with the order. So keybind and then associate with a key. So key. That way there is some type of code that kind of associates what the ordering is, right? So, right, because key 1 is going to be associated with paint 5D on the keyboard, on the num key. That's kind of like weird to do, but the idea is that these structs, the actual names aren't going to be referenced anywhere else in the code besides this file. So we can name it whatever we want, and I think that if we, num keypad, right, we could get really crazy. Right, we could call it num key, or num key, right, we could do that, right, we could do whatever we really want for this. I think, number key to press, I don't know, like something kind of like, right, number key to press 0, number key to press 1. Right, we can be kind of as verbose as we want there, and then, these are the actual systems that are associated. So we're trying to say that Taudepo would be associated with the key 0, paint 5D would be, associated with key number 1, right? And we are committing to this, like, hard coding here, right? And that could kind of, like, bite us, but I want rigidity and clarity rather than flexibility, right? So we gotta kind of take that and a trade-off, right? We can't have everything. Everything is a trade-off in life. To think otherwise, I think, would be misguided. So this will be to-do O2. Right, and we'll kind of keep, right, we have those to-do objects, which are going to be eventually filled out, but let's keep on stubbing in the to-do namespaces for things, just because I think it's going to make it easier when we actually get a second system, the system after paint 5D. We'll just be able to, in a lot of places, just be like, find to-do O2 and just replace with whatever that system name is, and we'll be good to go. Now, obviously, I'm not doing 2 do 2, 3. I'm not going like all the way up to 9, just because I just need enough here to establish a pattern. So paint 5D and then 2 more. 3 is a pattern, so 3 is the minimum to kind of establish a consistent, a recognizable pattern in the code, right? So that looks good to me. And then in the initializer, actually, we're going to also do the keyboard comma hacking stuff. So we're gonna do actually maybe not. Yeah, we're gonna do it. So we're gonna do a U30 or IO8, doesn't really matter. UO8 syntax lax comma hack, right? And this is just, we're not actually going to use this variable, it's just here to help make this a little bit easier, right? Because then we can go syntax lax comma hack equals 0, and we need a dot in front of this. So in our initializer list, we got to go dot to access the property, and then for every single thing after this, we can put a comma in front of it now, right? So we can go comma Taudepo dot whatever, 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 and we don't have to to do. We don't have to worry about if we shuffle these around, we don't have to worry about that first comma, right? We can just keep the commas in front like I like them and not have to worry about, right? Because if we try to shuffle this to the bottom, we gotta like remove the comma here and then add the comma to here. So the idea is that syntax lax comma hack, it just stays at the top like that, just to make it easier for the code to work, for me to work with the code. And the price I pay for that is adding a extra byte to RAM usage, right? So it's kind of a dirty hack, but I like it. So so these, we need some type of members, and I'm gonna say we're just gonna say CHR nothing to see here. We're just gonna call that nothing to see here. Nothing to see here. And I am being kind of cute here, but the idea is that I don't actually want to use this slot right here. I just want to yeah, I'm not actually using that slot, so we need dots in front of this. So just to confirm, just to kind of acknowledge that this system is here, right? Nothing to see here. We'll just put an underscore there, that's fine. And then we need kind of entries for paint 5D. So I don't really know. Well, actually I do. So P5D left. So left, right, up, and you'll notice, yes, that I do this weird thing where left, right, up, and down are all truncated, and then up has extra P, because up is only 2 letters, but I want to keep everything to 3, and keep just everything kind of homogeneous. So left, right, up, and down, and I had some keys in mind already, so I'm thinking ESDF for up, left, right, and down, rather than WASD, because I use Control-V a lot, and I'd like to give my pinky a break, and WASD is not going to give my pinky a break. So rather than have problems with that, I'm going to just shift everything over and use ESDF. So left, so let's go left. And we're going to keep everything capital, right? Like, the characters need to be capital, because we're not going to distinguish whether or not the case... To keep case insensitivity, we're just going to keep everything capital. And that's kind of my convention. So F, then up, and then down is in the center. Okay, so WASD, so you still have the S and the D that is in WASD. So if someone tries WASD, when they try to go down, they're going to go left, and when they try to go right, they're going to go down. And the other keys just won't work, but that'll give them idea, hey, the movement keys are somewhere else, but it's not so shifted that somebody's not going to find it if they just try WASDF. Unless they just, like, are really fucking lazy and they just try W and they're like, oh, doesn't work, and they don't try the other keys, right? But I see when somebody's trying to figure out the keys that they'll mash WASDF, but that's a big assumption. So we are going to, even though different editors might have left, right, up, and down, we're going to prefix it with P5D to know that it's for Paint 5D. The reason is that between all these different systems, they may have slightly different keyboard bindings. So the keyboard bindings aren't going to be like one-to-one. So we don't want the same exact names for all of it. Okay, there's two concerns, actually. One is I want a token where I can easily search for this token and know that it is the up for specifically Paint 5D. Without looking at the qualifier here, I can tell exactly what the variable is for without, because I know I'm going to use some macros to shorten these prefixes, so I want the variable here to be unique enough that I can find it and know that this is left specifically for Paint 5D, right? The other problem, or maybe aspect, is you'll notice that for all these structs we're doing, we're not using some type of reusable struct. Like Taudepo is not a instance of keyboard bindings. Paint 5D is not an instance of keyboard bindings, right? There's not a common keyboard binding struct that all of these are going to instantiate. And the reason is we do not want tight coupling with these, right? We want to be free to define whatever keyboard binding scheme is applicable to that editor, and if we want to carry over settings from one editor to the other when we are switching editors, we'll just write logic to copy the settings when we switch between the editors. So keyboard bindings for each subsystem are intentionally loosely coupled. Each subsystem's keyboard bindings should be an instance of a unique type and if now, this might be a little problem with the manual copy. Like, what if like, there's a problem to think about. Say, editor 1 and 3 have things in common, and we switch from 1 to 2 to 3, so how do we solve that? And I'm not sure how we're going to solve that. One thought is when you are going to a destination, when you're going to certain destination, all of the different editors have the, I think when you're going to so answer, so I think the answer is this. Answer. You keep a list of previously visited editors. And the most and so this is answer too complex. So this answer is too complex. Like, I like the idea, but now there's a whole bunch of different code execution paths, because you could have, the more systems you have, the more permutations you have, and so you could have tons of different orders in which the systems were visited. So that creates a lot of instability. So, bad. Too many permutations and execution paths. So this is bad. We're not going to do it that way. What we could do, what I'm thinking is answer number 2. Every time you switch editors, all systems oh, you know what? Answer number 2. Any settings that are common between any two editors are put into a common bindings struct. The common bindings struct is persistent, and it is so I think that's actually the solution. There's actually a third solution, which is the most elegant solution. Answer number 3. Fuck this. Just don't encode. Don't share. Right? So this is a valid solution, number 1. And this is valid solution number 2. Just be, fuck it, don't even do it. Don't add more complication into our life. Just ignore it. And pretend that, just be like, nope, we're not going to do that. Each editor just has its own state. And we're not going to try to, like, translate state from one editor to another, because that's too hard. Fuck it. It's just a user-friendly feature anyways. And move on with our lives and try to do something more important, right? Now, I just think it'd be a user-friendly feature for our artist if we do something like this. So with that, we're not gonna. We have some thoughts on how we want to do this, right? So a lot of thoughts, but we're not going to worry about that right now. But I wanted to write down those thoughts while I have them. Too complex. Do not Okay, so I just want a note of, you know, why am I not going to do something like this, right? Okay, so we got left, right, up, and down, and then we need tile size. So I was going to use W and X for tile size. So dot paint 5D dot P 5D, and we're going to do tile size exponent next. So E and N, right? What is E and N? And that's going to be exponent next. I don't know. Maybe we're getting way too terse here, but, you know, but, I don't know. So, paint 5D dot P 5D exponent so this could be, and also we don't want that, we want X. Tile size exponent. And B for back, right? Want to go backwards. So also known as previous, right? So we also need, we have the tile size. We also want to get and set tiles, and we also want, like, zoom in and zoom out, right? So let's take two more of these and kind of paste them. And so we want paint 5D, and we want zoom. Why don't we keep it kind of consistent and be like zoom next and zoom back, right? So that it's not zoom in and zoom out. Does that make sense, or do we want to like, how much normalization do we want? Because if we do it ZN and EN and ZN, does that make sense, or do we want to do like zoom out and zoom in, right? So that it's kind of like, well, I guess next doesn't really tell me, is the next zoom supposed to be deeper, or is the next zoom supposed to be further out, right? So I feel like we do lose some information if we try to do zoom next and zoom back, right? We don't, because so yeah, let's not try to keep it totally normalized with this. Right, we'll try to keep these variables more different. And zoom out, see more. And then this is zoom in, see less, but bigger. So E and D, is that what I was going to use? I don't know if that, no, it's not E and D. So zoom in is going to be V and then R. So zoom in. So I'm thinking that, we're doing V and R. It's kind of like our V and D, right? V and D? Not V and D, hold on. V and R. So V and R, the idea is that it's with your pointer finger, right? You're going to go up to zoom out. So out and up. Moving up. Moving up and over. Digging down. Right, so I'm trying to think, like, viscerally how the keys feel in terms of the shortcut. R is a motion up with your fingers, so that's kind of like zooming outward because you're like a plane and you're kind of going up. And V is kind of digging down, right? So W and X, we got W and X. It's the same thing where you have the up motion with, so W, feels like moving up, which is progressive. And then X feels like moving down, which is backwards. Alright, so I just want some type of tactile kind of association where, you know, the muscle memory just makes kind of sense with the way we're doing it, right? Same thing with this, like, R feels like moving up. Right, we can just copy this. So it's the same deal, it's R and V. So R and V, same thing, right? So we got the what we think makes sense for the tile size, right? So tile size. Zoom in out. And what else did I have that I wanted? So we want a way to get and unset a tile. So, so dot paint 5D dot p 5D su equals G. So that's set and unset tile, right? Set and unset tile. Or you could do set and remove. I don't know. We do S and D, set and delete tile. Or we could do toggle tile on off, set unset. Right. So the idea is that it makes a lot of sense that when we press if we have a certain type of tile and we're like you know, clicking to set down that tile. If we click once and we set it down, well, what should be the behavior when we press the key again, right? I think the behavior should be to toggle, right? To turn it off, turn it off. Turn it off, turn it back on again. And the reason I think that should be the behavior is because then you get kind of more bang for your buck with that tile, right? The set tile is also the erase tile, which makes a lot of sense, because then you don't have to switch back and forth between a pen and an eraser, or use a different key, right? I think that kind of makes sense. That kind of makes sense to me. Now, maybe that'll come back to bite me. Maybe I'll be like, I can't really draw very nicely when I do that. I don't know. Well, actually, no, because we can use, like, the mouse to, like, click, drag kind of paint. But yeah, I think that works well for that. So we want a next tile and a back tile. So we're going to use T and B. So T and B, same thing. T is up above, and B is below, right? So in terms of home row, right? So, and then G is in the middle, right? So G is in the middle because it's G in the middle because is both plus and minus, right? So viscerally, G is in the middle because we're not going up, we're not going down, it does both. So that actually is kind of consistent with the visceral kind of behavior we're trying to get. So paint 5D.P 5D, and we want just the next tile. So exponent next. So when we're talking about the tile, the next tile, what we really are talking about is we're talking about the tile's value, right? So the value of the tile. So this is tile size, and when we're talking about the tile type, we're actually talking about the value of the tile. So we'll do value next equals, and then T, and this is value of tile and next, right? And then same thing here, so paint 5D.P 5D value back, right? We're not going to use P for previous, and we want to be consistent with how we do that, right? So with this, when we're going back, we want B for back, actually. So B, and that's going to be value of tile, B for back, right? So with that, I think that's everything I need. So we have notes on why we're using certain keys, the way we're using them. I do kind of like not actually want, like I like having these notes here, but I think that the notes are actually really cluttering this. So so what I'm going to do is I'm going to take these keys here, and I'm just gonna, in my hashtag file, so we're gonna open it up, or not here. Oh, what am I doing? So in documentation, I have this hashtag file. We're gonna take everything and be like, you know, we're gonna call it paint 5D key binding justifications, or how about reasons? How about justify reason? I mean, justify reason, that's kind of redundant, but the idea is that we're just gonna keep the commentary, like the notes, for why we're gonna bind what we do. We want the muscle memory to be intuitive. the high keys go forward, the low keys go backwards, the mid keys are not directional. So forwards, Q. Okay. So the high keys, the low keys are these guys. And the middle keys are in the middle of the keyboard, so these guys. And we're making an exception for exception E F for WSD light. Okay, so this is just a little justification, and then we're going to keep our like little verbose kind of notes down here, and we're going to actually remove them from the main file here, because I think this is actually kind of, it's just cluttered, and I don't really like it. So I think right, just having this kind of list here, and then if we could get something where so this kind of repeating here is kind of annoying. I think we can use another initializer list and do something like I think we should be able to do something like dot paint 5D right, like this. Put a we should be able to nest our initializer list, but then once again we have this keyboard hack. So I'm just gonna do a I think they're gonna that's not gonna be allowed because it's more than one underscore in a row is kind of reserved. So we'll do like XXXXX. So we'll just do that for so CHR for character. We don't have that namespace yet, but the thing I don't like about doing what we're doing here is the extra redundancy of having to, we gotta list it here, but then we also gotta like list it there, right? So it's like, it's in like two places, and that is actually kind of like annoying, that we can't like just define it here and then set the initial values. That is kind of annoying, but you know, I hate all languages. Different languages have different strong points, but they all have things that annoy the hell out of me. So let's try not to worry about it too much. Let's use some logical separation between the different categories here, right? So so this is tile value. Move, tile toggle, set and unset. And then over here is tile exponent, also known as tilexp. And this is zoom in or out. Okay, so we're not gonna, right, this one's next, this one's back. I don't know if we want to, sure, why not? Next and back. Out and in. Next and back, out and in. And this is still like next and back, right? Next and back. And then, you know, this is left, right, up, down, right? Left, right, up, and down. It's kind of like additive or subtractive, depending. I don't know, just like trying to make a little thing here, right? The next thing is, you know, maybe if we want to get designy, dash line I2 x64. So we have like a nice little divider line. And everything is kind of organized now, right? We have a nice little lookup list. This is a hack. This is a lax, comma, hack. And let's see if that's in our documentation. Do we have lax, comma, hack in our documentation yet? No, we don't. So let's just take that and put it in here. A variable whose only existence is to allow me to put commas in front of the variable of right, so a little example of what I mean by lax comma hack over here on this screen. And then we can say, do we like these, or is this too much? Is this too terse? Are we just like, you know, are we out of our mind right now? Well, we have this little list right here. So we have the list, and then when we're looking at the function code, we can keep this list open, right? So it's not like we're gonna be like, oh my god, what the fuck does that mean, right? We can actually see the, we can actually see a little table, right? The idea is to consolidate everything here, so we don't have to be confused. We have a nice little consolidated reference file, right? So then here, Paint.5D binding choices. Okay, I need something a little bit shorter, so let's call this Paint.5D binding choices. And it would also be nice to see this here, where it's like where we have a little list, I think, where it's move left, move right, move up, move down, value next, value back, tile type, toggle, set or unset tile. Then en. What is en? Next and back for something. Exponent. Tile exponent. And then zoom out and zoom in, right? So just a nice little thing here. So we have this table, and then we have this table. So what we could do is we could have this as a more fluffy kind of reference, maybe, and then over here we can kind of keep it a little bit more dense, right? And that way, this denser reference is where we can look at all of the related keys between the different systems, right? And let's just put the lax comma hack in like everything, because then. Oh, and I put that in the wrong spot anyway, so this is all in the wrong spot. So that is right there, paint 5D. And then CHR, 1, 2, 3, 4, 5, 6, 7, right? And lax comma hack. We're just gonna keep that these lax comma hacks in instead of being like nothing to see here, why don't we just keep on using lax comma hack? So there's nothing in here. Oh, I see why I did nothing to see here. Let's rename nothing to see here to keep this struct empty. I'll just call it keep this struct empty, so we're not actually going to use it. We're just going to name it as something to let us know that we want to keep this empty. And, right, we have the XXX right here so that we can, keep the lax comma hack. That's what this is for. It's just a lax comma hack, and we also have denoted it right here. And then for these other systems, we don't really have anything in here, right? But let's try to kind of like open up the initializer lists in the same way that we're doing over here. And that way it'll be easier to add on to this later because we'll just see the structure of this list and we'll be good. The enforced white space by having this bracket right here, I think that's okay. Maybe we'll want to consolidate that at a later date, but right now I think that's okay. Dot 1, 2, 3, 4, 5, 6, 7. Okay. All right. So that looks good. I like how that is looking. I think we've kind of fleshed out the thought for how that's going to work. Now, as far as keybind.f, the function file, keybind.f, keybind is a data-only namespace. No functions here. So we might need like a, do we want like a no init? So we'll name this as well. So going into our library, we're going to call this keybind dot. Is it really key bindings or is it really just key associations? ASSOC. Yeah, because we're not actually doing any bindings. But you know what? I think keybind is fine. Maybe this should have been called something like key sock or keyboard. Yeah, yeah, I think maybe I'm just being... I think I'm splitting hairs, right? As an idiom for... I'm looking too much at unnecessary details. I don't think it really matters. I think it's inconsequential. So... let's not worry about that. I think it's good this way. And we're ready to kind of like stub it in, right? Like this isn't, we don't even know if this is going to work yet, because we still have to stub this code in. And there's the potential that maybe my syntax here isn't quite correct. And also, there is some things I have screwed up here. We need to define U08, and we need to define, can we do CHR? Define CHR, and it's going to be just a char. Do we want to do const char? Do we want to just be like, don't change the bindings at all after the game start? Nah, I don't think you want to be that rigid. There's definitely the potential to yeah. So U08 and char. And, you know, I think that we potentially could just indent. We have enough space to where we could do some extra indentation here, right? So we have enough space. We can afford the extra space to keep with our standard of the way we indent, right? We can maintain our standard of indentation. So 1, 2, 3, and 4. Right? And everything isn't, we haven't violated our column. Well, we kind of violated it right here. Yeah, and then right here we can do library struct, right? So we can say library struct. And then we can make a nice little divider line. And then we also need to undefine this stuff at the bottom, right? So right at the bottom. We just want to keep a consistent kind of style here. And what the fuck did I just do? We want to keep a consistent style with how we're doing this. Library struct. Okay. So yeah, I think I like that. That's a nice style. So we got U08, we got char. There's really nothing else in here. We do want to make a note that all bindings should be uppercase. Okay. So, there's also, keybind. So we also need the fragment shader testbed stuff, right? And we need something for the number keys, right? And we just need, we're really just giving them a name. So FTB, fragment shader testbed. Or, fragment shader FST. Since I can't really think of what the abbreviation needs to be, we're gonna do just, the first 3 letters, I think. Or we could call it bed, because bed is kind of like a word. Because it's the test bed, the fragment shader test bed, so maybe we could call it bed. Maybe that's the appropriate abbreviation. I know I'm kind of breaking my abbreviation rule of, like, first 3 letters, because if this was Paint 5D, then it should just be PAI, right? But, I want something that kind of is, I want an abbreviation that's going to be easy to memorize, right? So, Paint 5D, P5D. I think that's going to be easy for me because it's Paint, 5, and D, right? You're just taking the 3 words and you're just mashing them together. Now, the problem with fragment shader testbed is fragment shader testbed. They're kind of like 3 words, right? Fragment, and then shader, and then testbed. So FST. But then testbed, you could be like test and bed, so FSTB, right? Or fragment shader test. Yeah, so the depending on how you break apart those words, you might see the divisions in different places, right? So I can't really make up my mind of where those divisions should be. So another good choice would be, well, since we can't figure out what the divisions are, just take the first 3 letters and call it frag, and then something, 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 right? Frag this, frag that. But I think that calling it bed is better. Like, it's the test bed, right? I think that's going to be easier. And then we can just do, like, this bed 0, 0, 0. Test bed, so this is shader slot 0. And then ready. Paint 5D. So, so these slots are still available, where you could override them in the mod folder, and it wouldn't have any effect on the program. And as we kind of like, we're going to override the shader code for each of these slots as we add different systems. Right now, the only shader we've overridden is this. Shader slot 0 is not associated with any subsystem. It just gives us this iReady shader, just to give us some positive feedback that everything's set up. But yeah, so we can just give them numbers like this, like bed this, bed that, bed that. And that way, when we're trying to look for the keyboard bindings for the fragment shader test bed, we're like, where the fuck was the keyboard listener for that, right? Where the fuck is the keyboard listening code for these fragment shader keys, right? Well, now that we have this this centralized area for the keyboard bindings, if we need to find that, we can just be like, okay, well, click this, and then search in the code base for this specific token, right? So we want this token to be terse, but we want it to be unique enough to where it's probably only going to be used in this context of the frag bed. So fragbed.bed, right? So we want terseness, but we also want uniqueness. We also want variable names that we can easily memorize. Right? We want consistency. There's a lot of things we want in our variable names. And so I've developed kind of this very rigid variable naming scheme just as a way to make it a little bit easier to think about what the names should be. Because, man, figuring out names is hard. And the more constraints you have, I think it's the easier to find the one correct option. Well, if you don't have any constraints, then there's no one correct option. But the more constraints you have, the less correct options you have. The less correct options you have, the less you have to decide from. The less you have to decide from, the faster your decisions, right? So by adding a whole bunch of constraints, it actually makes the thought process faster. Okay. So yeah, fragbed isn't really associated with a number key like everything else. So we'll do like a dot fragbed and equals, so we'll put a little initializer list here. And let's be consistent here, right? So if that's the way we want to do this, let's be consistent, right? So that is, if this is, you know, we're keeping this struct empty, so maybe we should put this one at the top here. And that way, when we're, right, because this isn't going to move anywhere, right? This is just, it's just here, right? And we want to consolidate all the meaningful information in kind of one spot, right? So we're really going to ignore this one. And do we just want to consolidate that space and be a little bit inconsistent with the formatting and be like, we're not really going to use this, so just, you know, account for it here, but then... Or does that make it easier to miss? I don't know. I think I'm just being a little bit too picky again. So yeah, we'll take all these variables right here, and we'll just shove them into here, and then we're just going to assign them to the number keys, right? So it's not going to be anything unique here, right? So just going to do comma and then dot, and then also we need that dot xxx variable, dot x. So this is our hack variable, right? So that we don't have to worry about the lax commas. And so we also have to add that in here, right? We gotta add the lax comma hack. So let's take this and just paste it right here. Make a little room. And I'm good with that. And then we'll just associate these to their respective, is that correct? Something's wrong here. Why is this? Oh, I see. So this equals, you know, we're just gonna, now we have a little bit of indirection, right? We're adding indirection, but the thing is we're not adding too much. We're adding indirection, but the amount of indirection in the code is not directly proportional to the amount of mental indirection we're adding. We're adding less mental indirection than we are adding physical indirection, right? Because 0 maps to the 0, 1 maps to the 1, 2 maps to the 2, 3 maps to 3, etc. So it's not that bad indirection-wise, right? Because you know, we haven't really added extra mental indirection. No extra minimal mental indirection. Right. So we can make a note of that, can make a note of that, of what we're talking about in here in the comments. And we can make a note that if, example, AAC 2020 keybind.frag Okay, and then we'll say written on date and 2020 12/13. So minimal mental indirection, right? Not a T. Need more T. So that's kind of what I mean by that. And now we have this tag in here. We can search in the hashtag documentation, right? So we are about ready to kind of stub this into the code base, but before we do that, we need to make sure the code base actually runs, right? So we're going to open this, and we're going to give it a run, and hope to God that it actually works. And I mean God in a purely saying kind of a way. I don't actually believe in God. Like I know people say, you know, Einstein said God doesn't play dice. I don't think that Einstein meant that he believed in God. I don't know what Einstein believed, but I'm pretty sure he meant a proverbial God, right? Like he meant God as in like nature, or God as in the universe. But yeah, some people take things a little bit too serious, or maybe too much at face value. Like, I mean, I have this strange suspicion that everyone who has ever said, "Oh my God," they're probably not all, you know, they're probably not all monotheists, right? They're probably, you know? Okay, so yeah, we're good. I mean, it works. It runs. So we need to actually stub in the system here. So we're not just going to tack it on to the end here, right? Because we're trying to refactor so that any system that's using keyboard bindings is going to kind of like have access to this. So what I do see here is I see that we have, you know, native keyboard and iKeybox right here. So native key and then iKeybox and iMousebox and etc. I think it would make sense to put the keyboard stuff right in there. I think since we have iKeybox and iMousebox, I think putting it before iKeybox might make sense. It doesn't really matter, right? It can be anywhere we want, but like a lot of this is just static information, right? So it's a nice place to put this information in the first place, and then it doesn't really matter where the order is really inconsequential, but we want an order that kind of makes sense and is easy to follow. So I think that iKeybox and iMousebox, they're kind of related to each other, right? And then we have this other key thing, and the keyboard thing is actually kind of related to it's still a static lookup of stuff. Native key here is like functions. So I know that native key kind of like is used indirectly to populate iKeybox and iMousebox. So I want the keyboard stuff to be either somewhere either inserted between these two or before or after these two is where I want it to be. And where should that be? I don't know. We got to think, is there any case in which we would ever, if we were trying to refactor, where we would want them to reference each other, right? I don't think that would ever be a case. But let's look at the systems, right? Let's look at them for a second, and let's look at iKeybox.data. And yeah, so the key pressed, and then if the key is dirty or not. This is the actual key pressed. So I actually kind of don't want. I actually would not want this to know about the key bindings here, because this should not know about the key bindings, right? Because this iKeybox should be the actual key, right? There shouldn't be that abstraction of the what that key is. So we never want to like do iKeybox.keypress equals bad000, right? Because the key press is actually what's happening on the actual keyboard, right? So since I don't really want this to know about the keybind, then I think putting keybind, keybind right in the middle between iKeybox and iMousebox might actually make sense. Now that is a little bit weird because we have iKeybox and iMousebox are kind of like related to each other. So it's like, maybe we should do it after iMousebox. Right, so like right here between 6 and 7. And let's look at iMousebox. So iMousebox is just another data struct. So X's and Y's and things. And I think that I like how these are all kind of related to each other, these three here. So maybe I don't want to separate them apart, but I want the keyboard stuff to be close to this. So I'm thinking that it actually should be, I changed my mind, I think it should go in here. And now these decisions are kind of like arbitrary, right? But just because it's arbitrary and it doesn't really matter, doesn't mean we shouldn't kind of put some thought into it, right? Because by defining this, right, because we're being very strict about the ordering of how we're including things, it's part of that is to prevent people from doing things improper just because we know to-do man can't reference things up here, right? And then file boy, you can't reference anything up here, right? And then iMouseBox, you can't reference anything up here, right? So so we got to be careful where we're putting things because we're kind of communicating something there, right? Well, of course, we're always communicating something, right? But we're communicating that, you know, GL bindings can't reference anything up here. So the GL bindings can't reference the GL constants. That's an interesting statement, right? So all these are, there's a whole bunch of implied statements here. Pix name, it can't reference GPU data. GPU data can't reference these things, right? So by having this very strict ordering, we can layer on top of the systems, and we can have a very coarse general overview of like the entire system just in a glance, because we can see the exact ordering of how everything should go together, right? So I think it should go in between 6 and 7, so we're going to go after iMouseBox. So since I did a lot of talking, let's just make sure that I haven't fucked up anything. And it looks like we're fine. And let's get to actually inserting that code. So so we're going to have to shift everything over, right? So we're going to have to go, we're going to have to define macro libchan order, and we're going to call it keybind, right? We're going to give the exact same name of the system. Let's put a 7 there. Keyboard bindings. Keyboard bindings. And then make sure we type this correctly. We could have just cut and pasted, but yeah, we did type that correctly, so we're good there. And now we have this 7 and 7, right? So we have to take this right here, and we're going to overlap, right? We're going to go over here, and we're just going to overlap and paste. And the next thing is we want to make sure that everything is nicely aligned. So it looks like the ones place is in the middle, and then when we go to the tens place, we're actually shifting over, right? So I am being very meticulous about how these numbers even appear in these brackets, right? I'm trying to be super meticulous about how this works. So now we're currently going to compile all the way up to 21, right? Because we added another system, so the highest compilation unit is now up to 21, right? And now we need to actually open up we can close these. And we can actually close key binding as well. And let's look at libchan, right? So libchan is kind of the guts of like where this is all happening. So we'll open up the bottom and top file, and we will move the bottom file over to the right, right? So the top will be on the left, and the bottom will be on the right, right? So reading from left to right, right? Left to right. And also, if we're reading Japanese, we'll be reading from top to bottom. So just trying to keep a consistency here to how we're doing things. So I'm very rigid in the way I like to do things. So let's look at this. So we got this big list here, and we should probably make a note of where we're inserting this, right? So we know we're going after iMouseBox, right? So this is what we're going after. Let's just, everything is after iMouseBox. So after iMouseBox, making a note of that, and I'm going to pay attention to that as I'm doing this. So now let's look for where iMouseBox is in here. So we have to-do man, native key, DUI. This actually looks like things are out of order. I know we shifted everything around before, but okay, we got silence, we got to-do man, we got file boy, we got native keys, and then all of a sudden we got GenoWin. So now it's not necessary that this all be in the exact order that it's in, but it would be nice to always maintain the exact ordering, right? So after native keys, we have ikeybox somewhere. So is ikeybox actually in here, or did we just totally forget about it? And we were stupid about that. It looks like we were just stupid. Okay, so let's actually add that in. So let's see, we got native key, we gotta get ikeybox in here. So let's take ikeybox, let's just paste this, and we're gonna call this ikeybox here. Ikeybox. And then right here, we're gonna call this ikeybox. Ikeybox. Okay. And then we're gonna go down to keybind, or no, iMouseBox. So if we look here, do we have an iMouseBox? And we do not have iMouseBox either in here. So we're going to take this and we're going to copy and paste it one more time. And then we're going to call this iMouseBox. iMouseBox. And then we got to remember this variable over here. That's kind of tricky. iMouseBox. Okay. So keybind. Keybind is a completely new system. We know it's not here because we've never had it in here before, so we can just paste, and then we can include keybind. Okay, and then also we got to remember to get this one right here, keybind. Now, the ordering here doesn't matter, right? The ordering on the left side of my screen matters. The ordering on the right doesn't matter, but it does matter that I have every single system accounted for. So since it doesn't look like I have every single system accounted for, we can go through here and kind of like do a nice little cleanup and make sure everything is accounted for. So C-editor, do we have C-editor down here? So it doesn't look like we have C-editor either. Yeah, we don't have C-editor as well. So let's look up here. Yeah, so let's copy this again and paste it. And we'll write C-editor right here. So C-editor, C-editor. And then right here, we're going to write C-editor, right? And, you know, we could probably just have some way to automate this and create this. But that gives us maybe too much leverage, right? And the extra leverage creates extra flexibility, which reduces the rigidity, right? So, so this is, I would actually like to keep the tedium and the rigidity to this, just because its purpose is to be a redundancy, to help make sure that everything is set up correctly. And if I try to automate this so it's not redundant and it just auto-generates, then I've kind of like defeated the point of creating a redundancy, right? So C-editor, okay, Gina Win is next. So if we look at our list, Gina Win is next. And we see that is already there, so we can cross Gina Win off our list. And we see that DUI is after that, so we can go on after that. Let's cross that off our list. So GLEBIND, so GL Easy Bindings, that is next, and we can cross that one off our list. So GLBind, actually GLBind and GLConst. Let's just cross both of those off because I see them right here. And then we have the uniforms and the GRAQUAD. So CPU, uniforms, GRAQUAD, and free. So all three of those, let's cross those off of our list because I see them in that order. And then down here, let's take a look at this. So we got fragbed, oh, sorry. So after free, 1, we have fragbed, pixname, GPU data, pixload, Taudepo, and paint5D. So that's all of them. That's all of them. They're all accounted for right there. So we're good. Now, we could do like a little checksum. So let's actually highlight each one of these because this is the part where I usually screw it up. So we want to get to 21. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. Okay, so those are all accounted for. Let's go look over here. So we have these redundancies where everything is nicely ordered, and so this is less likely to have been have anything omitted because just of the nature of having a sequential ordering. And we know that we want it after iMouseBox right here. So we should make a little opening right here, and we see that iMouseBox is 6, and then the key bindings is 7, right? So we're going to take this, these are these little clusters of 3, right? We're going to take one of these clusters, and we're going to paste one right in here. And then we know that this is no longer cEditor, but this is keybind, right? iMouseBox, keybind, and then cEditor. So keybind, and that's 7, and then... right, and then we want to just copy everything down. So we're going to take everything here like this. We're going to cut it out, and then we're going to go space, space. Then we're going to go over to this 7, right, where we're overlapping. And then we're going to paste that down there. And then we've kind of moved everything up. And then we're going to add in a 21 right here. Okay, and so that's the nice thing about being so uniform, is that I can make those mass edits relatively quickly, right? So, I mean, that kind of, that's kind of like a, I don't know how I feel about that, right? Because that means that the way I write my code is kind of dependent on the type of editor I use, right? If you don't have an editor with good column selection, right? If your editor does not do column selection well, my code base is going to, like, infuriate you, like, absolutely infuriate you. And if you code without a mouse, and you don't have that fine-grained motor control over, like, clicking and dragging, and you're just a keyboard-only person, my code base will also infuriate you, right? Like, it infuriated one of my bosses. So, so let's look at this. So, keybind is at 7, right? Keybind is at 7. Okay, let's keep on going down here. And this is just, we want to put it right after iMouseBox. So let's duplicate this. And now this is keybind. And we want to take these numbers and we want to shift them up. So let's, so let's do that. And this is 21 now. Okay. And these are just, this isn't completely necessary. This is like, if someone else was using our code base in their project, we wouldn't want to, like, pollute their, we would not want to pollute their code with a whole bunch of defines. I mean, these defines are pretty damn specific, so, like, the pollution probably wouldn't matter. But, we still want to be courteous and just not do that, right? So we want to clean up after ourselves. So we got the library chain, and we did the bottom. We didn't do the top. We did the bottom, but we didn't do the top. Why did we do it in that way? I don't know. So we know we have 21 items now. So we're gonna put 21 here, and then the library chain max is now 21. And we need this variable here because this is just a check that if we go over the compile limit, that we're using an invalid range when we're running this build system. Right? I say build system, but it's just source code, right? I'm just using macros in my source code to create kind of like a build system, right? And the idea is that just to keep things as simple as possible, because I use bash a lot to build things, and there's also like cmake. But I'd like to be a lot simpler than that. So instead of bash and cmake, why not leverage the actual C code and do as much as possible just in the actual C code? So that's kind of what we're trying here with this. Okay. So we need to look for number 6. So right here, we're going to make our insertion. And this will be 7. So we can rename this 7. And then right here, we're just going to call this keybox. Or, not keybox, Jesus. Keybind. And then we're just going to have to go down and we're going to have to meticulously rename this. And, you know, there has to be a breaking point to, like, how big does this project have to get before, like, I'm like, screw this. Well, hopefully, oh, that's bad. So we want to make sure we have very consistent with these macros. I don't know if it's going to have a redefinition error if one 10 looks like this and another 10 looks like this. I don't know if that would be a problem, but we want to make sure that we're absolutely consistent so we don't have that problem in the first place. So right now we're kind of like putting the 1's place in the middle and then the 10's place over to the left. So we want to be consistent with that. But yeah, I don't know how... Right, all this shifting over can be, like, really annoying. The idea is not to shift over like this, though. The idea is just to add on, and going backwards means that we're adding something we didn't think about, right? But sometimes it makes more sense to make to go back and make an insertion. Because we don't... To have the order of the library as just, this is the order of the library because this is the order that we thought of adding everything in. That would be nice to keep a historical record of everything, but if it's bad for the functionality, then we should prioritize the functionality and not like some type of historical record. So while I like that the library chain design I have here maintains some type of chronological record of when things were added, things sometimes need to be meticulously inserted because the functionality takes first priority, right? Okay, so we're up to 21. We can do a little double check. 21, 21, 20, 19, 18, 17, 18, 17, 16s, 15s, 14s, 13s, 12s, 11s, 10s. And make sure that our placement 7 is keybind. Yep, KEYBIND.D for data. Okay, so now we can go down to the next section, right, into our functions. So our functions section should look pretty much the same as the other section with some minor differences occasionally, depending on the subsystem. And iMouseBox, we want to insert after. So iMouseBox will stay at 6. So yeah, let's take the iMouseBox. We're going to take it, we're going to paste it down there, and then we're going to rename these to 7s. And then we're going to call this keybind right here. So keybind for keyboard bindings. And then we're going to rename everything below, right? So we're going to increment everything and shift it down, which is tedious, but we want clarity of code over flexibility. That is the trade-off I'm going with. I want to be rigid and unambiguous. Have a very rigid structure where it's very easy to know where everything is, because we've kind of like gone about this tediousness to get that rigidness, right? So I don't want overly abstracted, flexible code. I want nice, rigid, simple code. And you might be looking at this and being like, what the hell is so simple about this? Well, what's simple about it is that it's just, right, once you understand the basic pattern, right, we're just repeating the same basic pattern over and over and over again, right? which is a common thing in the way I write the code that I write, is that I try to figure out the basic way to do something, and then all it is just repeating that way over and over and over again. And kind of batch processing all the operations so that the code itself kind of like redundantly explains itself over and over again, and you can kind of see the patterns, right? You can visually see that something is done over and over and over again, and then you can more easily pick up on the patterns because, well, it's designed. I'm designing the code to make apparent the patterns in the code, right? I'm explicitly being mindful of that and trying to expose the patterns in the source code. So when you glance at it, it has a visual appeal that exposes the patterns that are part of the code. So, I mean, this looks good, but I just double checking is good as well. So I'm just making sure that all the numbers are correct. Okay, so the numbers look correct, and are the numbers correctly adjusted and aligned within their parentheses? And that is also correct. So we're good there. You could also, yeah, so we're good. So everything is in its place. With the function macros, we don't really need an initializer for the keyboard bindings. We could make a no init function, but because the keyboard bindings come before the window code, it's not in the segment of initializers that are kind of all clustered together with the F macros. So if we look in F macros, or no, if we just look in the function file here, so if we look in the function file where I'm doing all the work of joining everything together, we see that right here, all these initializers come after the window code. So everything after KEYBIND needs like an init or an init none function, right? Because we're gonna just initialize everything and account for everything at this point. But everything before the window code, it's kind of like a toss-up. Everything is kind of, the initialization for everything else is kind of like scattered, and it's horribly organized. I would really like to have all the initializers just be like one solid section of initializing everything on startup, rather than a weird section where we almost have a strip of all the subsystems initializing, and then the older subsystems are like initialized before. Like, that's kind of dirty, and we need to fix that eventually, and give some thought into how we're going to do that. But for now, we don't have to do that. For now, we're good. So let's give this a run, and what I'm hoping is that the only error is going to be a syntax error in the right here, syntax error in the code I was working on. So I'm hoping that the library chain, all of that setup is correct, and the only thing that is improper right now is just the code that we wrote, right? That we made some syntax errors and some mistakes, and now we got to go into the keyboard bindings data file, and we just got to fix that. So let's look at keybind, and it's on line 98, and I think I'm good enough to where I can just ignore what the message is and just be like, line 98, okay, what's the problem, you know? And the problem is there's no dot in front of this, right? So dot this, right, because there's a property accessor, so there should be a dot before this. So let's look at the actual message. Keep the struct empty, undeclared here, not in a function. So that's not the error message I would expect. And that's why I kind of just looked at the line number to see what was wrong, rather than, you know, look at the message first, because goddamn, the messages never make any sense. So let's put a dot right there. That's probably all we need. And let's just give it another run and see what happens, see if that works for us. Keybind is a data-only namespace. Unknown type name, keybind. That looks like a comment. Did we not write our comment characters correctly? Probably. Line 4, that's pretty up towards the top, is it not? Unknown type name keybind on line 4. What? On line 4? The line 4 is commented out. What the fuck? Oh, wait, it's in the function file. So the function file, which I didn't even think to look at because it doesn't have any code in it. Yeah, because it doesn't have any code in it, so I'm just like, haha, just writing it. Yeah, be an idiot. So it has no code in it, but it still is a code file, right? So, now the reason why we have this function file, even though there's no functions, is that I'm trying to keep a very consistent, uniform pattern with the way I'm assembling everything together. So everything is functions or data. Functions depend on data, but data does not depend on functions. So therefore, that is why data is on the left and functions are on the right, right? We want to keep things in a dependency order when we are looking at the code. Okay, so let's give that another run and see what we got here. So my static assert failed, CPU info equals 12. Okay, yeah, because that's because we, I shifted everything over, right? So I know exactly what that's about. It's still an F, it is an F macros. I'm like, oh, we don't need to look at F macros this time because we didn't add any. But what we did do is we shifted everything over and we added this, like, extra rigidity that I don't know if we really should have. But these numbers are different now, right? And, you know, maybe it's more trouble than it's worth. I don't know. I'm not going to worry about it right now, but we're going to fix it. So let's, so I don't need to add any more F macros. Let's actually move the top file over to the right, just so that we can look at this nice little list over here. And we want to look at ikeybox and CPU info, right? So ikeybox and I said CPU info is actually CPU uniforms. This is a really bad abbreviation, which still can... it was a bad abbreviation, but whatever. I'm stuck with it. So, ikeybox is 5, and then CPU info we see is now 13, because it got shifted over. So we just need to change these 12s to 13s. And looks like other things got shifted over. So GraQuad got shifted from 13 to 14. And this isn't necessary, right? This is just extra redundancy added to, so I don't, just to catch errors. But you notice in this other code where I'm doing stuff, I'm just saying, you know, looking to see if it's greater than or equal to 1, rather than looking for its specific value, right? So if it's positive, it's defined. If it's 0, it's not defined, right? So I think that, you know, maybe doing this way was a bad idea up here, and that doing it the way I do it down here is a better idea. But let's not worry too much about it. Oh, and now we're in this informal documentation section, which we can also fix. So in keyboard bindings, that is right after iMouseBox. So we got to make a little section here and go keybind, and it's the 7 now, and a list of keyboard bindings, data only. It's a data only namespace. And then we can take this and we can overlap it with up here. And then we can put in a 21. And now we have this not guaranteed to be up-to-date documentation. And also, are we missing a... Let's fix that. Okay. So, let's give this a run. I think that all the problems are fixed. Well, I don't know. We'll see. Well, it's running. Okay, cool. So, we have the keyboard binding struct kind of stubbed in place. Let's look at the agenda screen here. Keybind, centralize keyboard binding. So, we've stubbed in keybind, but we haven't actually keybind. We haven't done a refactor, right? So so let's actually edit this again. This is getting long, but we got to think about like what we've done, and actually I'm gonna take this and I'm gonna cut it and I'm gonna paste it in a better editor because it is horrible to edit in OBS Studio. So we're gonna say that was number 5, and now we have a new number 6, which is keybind refactor fragbed bindings to fragbed okay. Okay, so updated that. Then you go paste it back in here. And yeah, so this is our updated list. So we've got, you know, we've shifted over our agenda numbers again. Before I would like, you know, give them like 5.5, 5.25, and give like more decimal places as we kind of like subdivide things. And that's a good way to do things so that you can kind of see, you can get an idea of like all the line items that we totally just weren't thinking about. So let's do the refactor of fragbed key listeners and get the keybind values into there. So let's go back to the code screen and let's close some stuff. You can keep keybind open, and we just want to open fragbed, and it should be the fragbed function file that we're going to look at, because we want to look at the keyboard listener code, which would be functions, so therefore it would be in the function file. And I already know that before we scroll through all of this, we should just be able to find like the one within a character string, I believe. Yeah, so here we go. So we see 1, and then we see this like shader found equals this, shader found equals that, and we're looking at the character key here. Now, this is a switch statement, which means that these cases need to be compile time constants. And so we have a problem here, which is that these aren't compile time constants, right? So if we want to kind of get that, we're gonna have to like make instead of putting these here, we're gonna have to like say that we're gonna have to create some defines, right? And you know, we could just do something else, right? But well, hold on. So if we use defines and then we want to remap this later, we're gonna have like if we want to remap it in real time, like load stuff, we're gonna be in a world of hurt. So let's not do that. Let's refactor this somehow. If we want kind of the structure, if we want to stick to the structure, so first of all, if So if we do, each of these are constant, so we got to think about what is more detrimental to accidentally overwrite, and I think it'd be more detrimental to accidentally overwrite this value. So we're gonna put the key on this side. So we're gonna use a constant for the key, and we're gonna say, if this or what we could do is we could get ridiculously so what we could do is, so hold on, let me put some breakpoints here. So up at the top of the file, what we could do is we could do define we could do define num1 as AAC 2020 keybind, and then fragbed dot bed 000, right? That's actually kind of nice, because then we can see exactly where it's being used, because we're doing the rather than kind of like using a macro to shorten this part and then kind of gluing it together with this, we can see the whole exact path to see where it's going to be used. So I kind of like that that simplicity, because we also have to think when we're making considerations as to how we're like, when we use macros, we can make it kind of like harder to like find relevant pieces of code, because we're like control Fing for something. But we used a macro to glue things together. So, like, if I use a macro for this, and the macro is blah, 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 the macro is blah, and the blah means this, then we can never find AAC keybind.fragbed.bed000, because we used a macro, right? And so when you are using macros, you got to be careful that is this macro damaging my ability to search through the code base, right? So we got to keep that in mind as we're doing this. So it might be a little bit like crazy, right? To be like, man, let's just throw these all in here like this, right? My thought here is that that this right now we can say that for now this is these number keys, and they might not always be number keys, but until actually no, we're not going to do that. These should be number keys 0 to 9, unless you've got a working editor already, and you absolutely need those keys for something else. Okay, so let's just making a note here. Actually, no, I don't think this is good, because, right, remember we wanted to make these variables terse but unique enough so that we could find them in the code. And I'd want to see the actual usage site for where bed00 is being used. So how are we going to get this shorthand, but then also be able to find where bed00 is being used? And the answer is all uppercases, right? So bed, so we shorten this whole namespace here by just uppercasing the whole thing, right? Because macros are supposed to be all uppercase anyways, or, I mean, that's the typical convention. So if we do it like this, then, right, we've added a layer of indirection, but the indirection isn't too hard to comprehend, because it's just like, oh, we're just taking this whole namespace and we're just shortening it down to the actual value we want, right? So it's not like it's not a big deal, right? Now, simple keyboard handler, we can actually highlight this, and we can kind of, we should be able to, yeah, grab the top and bottom, right? So between 687 is the bottom and 477 is the top, right? So this way you can jump straight down to the bottom, and we can add, so we have 3 sections of defines, so we got to undefine down here, right? So we're going to take this and just paste that there, and write undef, and we can remove these, and it looks like we had like a little checksum going, so we can kind of keep that going for now. I do like the way I was starting to do this with, well, you'll see. So 10 and 11, 12, 13, 14, 15, 16, 17, 18. So we got 18, so this should be 10, and this should be 8, so that's 18. So I think that it might make more sense to shove these all the way over here, because now we have like this, we have this big white space, we have this like room to breathe between this section divider and the code, and it kind of makes a very noticeable visual pattern here, right? And this also looks like a big bracket, right? Because we got this here, and then we got this here, so it kind of looks like a bracket. It looks like a bracket on the bottom that's kind of like containing this section, right? And you might want like a, since we have these different sections of macros, but we had 3 sections, we'll do like a dash line I0x64, and we'll put a little dashed line between that. Because we want to keep the white space, but we want to also be able to, like, you know, look at this, right? Like, line it up and see what we're looking at. So let's go up to the top and kind of, like, fix that around as well. So we have, we can't really do that up here, though, can we? Because, like, we just, like, these go, like, way close, too close to the border. So we'll just have to keep what we have there. And now that we have those constants, let's look at this again and see how we're going to fix this. But before we see how we're going to fix this, we were kind of mucking around a lot. So let's do a little sanity check, make sure we haven't broken anything. Okay, so sanity check passes, and we can continue on our efforts here. So we're going to, so the case statement here, these need to be compile time constants, so we can't do it like this. So what we could do is, you know, if chr key equals, 001. Let's just do this. So let's get a define for k for key. Go define k is chr key, and then down when we're done with it, we're gonna do like an undef k for key, and then what we can do is str equals P1, shader found, so one thought is we don't really need a break statement here. Like, we could get away with it not having that. Right, we could just do if, and just run all of these ifs, and in performance be damned. But another thing I would like to do is, I think we're running out of room, so let's take shader found, and let's just rename that to something shorter, right? So usually I use, like, when I don't know what I'm doing, I'll just use shader found. So it's really, it's the, So I would say foudex for found index, or dex fou would be best, because I think shader found is good, but I think it's more important to know that it is a index value, right? So dex fou, so the dex of found, and if dex fou is greater than 0, something was found. If dex fou is less than or equal to 0, nothing was found, and we do this like 0 stuff. So let's do that. So we'll just say shader found. We're gonna take the same variable name that we're about to refactor, and we're just gonna make a little comment here, right? And then we're also gonna check our notes. So dex fou, do we have a variable called that already? Yeah, we do. Fou dex. So we already have a variable called dex fou, and dex fou means, what does dex fou mean? Dex fou, index found, index of found item was index found. So we already have a shorthand variable in our documentation, or in my personal documentation of what kind of variables I like to use for things like this. So everywhere where there's shader found, we're going to use dex fou, right? And dex fou is very ambiguous, right? It's index found. So you're like, well, that's less information. But the thing is your function shouldn't be so complicated that that index found is somehow not enough information, right? So we're going to just replace all these locations with dex fou. And yeah, we can replace that. And the only thing we're not going to replace is the comment, right? So we're going to keep a little note of, like, if we need to think about what that is, we know what that is. We don't want to make more notes here, so we might actually want to make more notes. So so dex fou index found, index of found item. And then dex fou equals shader found. When okay, so I made some notes here about dex fou. Now, because the way I do my syntax highlighting, I want to have a little space for this to breathe, except now that can be kind of confusing because now it's not directly above this, but that's kind of the way I like to do it. Let's not be too worrisome about that. And that should be a trivial refactor, right? But, you know, there's no such thing as a trivial refactor, so let's make sure that that is still good. All right, cool. And now we can actually kind of like get in here, and now we have a little bit more column space to work with. So let's try to redesign this, right? So what we can do now is so dex fou starts at 0, right? So what we can do is if dex fou is greater than 0, we're gonna break. I'm gonna be a little bit fancy. Might regret this later. Might regret this later. We'll see. So undef break, and I am purposely typing in this way just to make it hard as hell to type, and also make sure that it's unique. And also to signify that, you know, I'm being kind of weird here. So what we could do here is, because we're going to repeat the same line of code here, like every single time. So because all we want to do is break maybe we should name it like that, break if found, right? And then we can do like a do, and then a while 0, a do while 0. Right, so the idea is that it runs once, but then it never repeats after that, right? So this is the way this is a very hackish way of creating switches that I tend to do. And you know, maybe it's just a horrible thing and I shouldn't do it, but this is the way I do it. So now this code is still going to be a bit longer, right? Because we were able to get the break statement kind of like on its own line last time. But now we've kind of screwed that up, right? We're kind of like, well, now we don't got that, right? So, so I would like to, this is a little bit cluttery. I like having that extra space there, right? The break if found, visually, that's very noisy. So I think that I do like being descriptive there. So BIF, break if found, and knowing key press. Right, so I do like I do like the being descriptive, but I'd rather be less cluttery. So with key here, looks like we actually have enough room where we could type key. Yeah, we have enough rooms where we could type key, so let's do that. So let's actually type out the whole word key. And so we've kind of just, it's a little bit of indirection, but whatever. So with this, we can replace all these, and I don't know why we're doing that, because we haven't even, like, so here, we need to take this, right, and we just gotta duplicate it. So let's actually open up one of my templates. So, Farc template, and we just want to take this piece of code, and we want to look for where there's a 1, and we want to replace it with a 2, a 3, a 4, a 5, a 6, a 7, 8, or a 9, right? That's all we're trying to do here. So if we run that, and then bam, all the duplicated goodness is, okay. So, oh, actually we want this indented, don't we, right? We want to kind of, so almost flawless, except now we got a little bit of extra tedious cleanup. Okay, so BIF is if dexFow is greater than 0. So you see that dexFow is right here, and so if this executes, then we're going to end up breaking, right? So it's a little bit like weird, but it'll work. Now we could also make a note, like if we want to say, let's say that, oh god, this is confusing as hell. We could also mark this. We could say, I'm gonna call it a do switch. Right, because it's do and it's being used as a switch statement. Let's call hashtag do switch so we can actually look it up. And so if somebody sees do switch and they want to know, like, what the fuck do I mean by that, right, we can actually see that, right? And so do switch is basically, I'm going to use a do while loop to create switch style behavior, but without needing a compile time constant, right? So that looks good to me, and we could actually just, for now, we could, so this info here, if it's not one of these cases, we don't really need that information. That's not really necessary. Let's comment this out for now, and Well, actually, let's take this and do, not a new file. Let's look into our hashtag documentation, and let's paste this, and then let's actually take the code here and actually put it into the documentation, right? Because now we have an example of what this is, and why not put it in the documentation, right? So, do we want to keep the indentation? I guess we'll keep the indentation. I don't know. Okay. So then we can use the same, like, little header thing and document what do I mean by do switch, right? Okay. So using a do while 0 loop to create switch like structure that does not require compile time constants for each case. Right? So that's example original switch statement 2020 1213. Example refactored into a do switch. Okay, so now we have like an example of like what we mean by that, and we wrote all this documentation, and maybe we shouldn't have done it like that, because like now we're like it's not completely a good example, right? Because we kind of like change things around, like this key here is str key. But oh, these aren't compile time constants. Instead, rules. Right, so this is kind of like what we're doing, and we can make a little, we can kind of highlight that a bit about, you know, this is what we're doing. This is the refactored version, and this is what we started with. Now, the refactored version is much more, I don't like this as much as this. Like, this is a lot nicer, because, right, you can column select everything and just edit it really quick, and this is kind of like, what the fuck? But the thing is that we didn't want to go over our column limit, right? So we had to make a compromise here, and I think that's a decent visual compromise, right? So you notice that, like, a lot of times when I'm thinking about the code, I'm thinking about, like, how does this visually look? How does this fit with my formatting rules? How do I not violate going over that edge, right? Like, a lot of my time is spent, you know, not going over the edge, right? Like, a lot of thought is given to that. And the reason is because I just want to be able to, when I'm looking at my code, I just want to be able to, like, go, like, up and down and seek to find what I'm looking for. And I never have to, like, grab onto this other scroll bar that's way down here, right? Because that's just annoying as hell, right? And maybe I'm misguided in thinking this. But anyways, let's go look for this biff thing that we wrote, since we can find the switch pretty easily that way. And then we'll just say, right here, we're going to say to do, or actually no, to do, delete this code. So we're gonna delete it in multiple steps. So we want to make sure that absolutely sure that we can get this running first, and then once we are absolutely sure that this little refactor worked, then we'll get rid of the original code, right? And that's just because, well, I mean, because it's a headache if we want to get it back and we already deleted it. Yes, we have version control, but that doesn't mean I want to start using git commands and complicating my day because I made a small mistake and now I got to go back into version control to find it. Like, no, I don't want to do that. So, but yeah, so the keyboard listener is still responsive. So we know that our refactor was successful. So you'd be like, well, what the hell was the point of like all that work we just did? And the point is let's say we close this, right? And we close this, and ooh, this is not saved. That is worrisome. See this little red thing? Let's Control Z for a second. Okay, so just like I must have been starting to. Oh, I was gonna do like a define or something. Okay, so let's say, you know, you're like, let's say you. Oh, okay, hypothetical here. So it's been a month. It's been like 3 months. No, it's been a year since you ran this project before, right? And you grab it, and you remember that the number keys do this, right? You're like, oh, number keys do this, and you're like, okay, that's cool. So how am I gonna find that out, right? So the first thing is you probably, if it's a really long time ago, you're just gonna search for those literal strings, right? So I guess let's go through it in that process. We're gonna look for the literal string. So we're gonna go Control H, and we're going to look for a 1 in a string, right? Because the number key, you press 1 in a string, and let's find in files, find all, right? And then we see, oh, these different cases. We see this is commented out. That doesn't count. Native key, what's this? Okay, and we see that. So here's a time to make little notes. Bed. This is just helping. This is just a comment to let me know where how certain things are connected later. And right, the comment could eventually be invalid, but I want to like design the code base so that I can easily search through things. So say this is the first string I grab onto, then these are going to link me to actually where I want to look. And also, we can also say I accidentally, instead of searching for within quotations, I accidentally do double quotes. So we could put double quotes here, and that way we have a little redundancy where if I accidentally search for double quotes, I can still find it. And let's go back to the frag bed stuff, and let's take the stuff that we said we were going to comment out, and let's actually do that. So if we can find it in here, I don't know. This is a lot of stuff. Oh, here we go. It's right here. So let's delete this code right here. Okay. And let's try that hypothetical over again, right? We know that, yeah, we won't reload it. We know that when we, let's run it again, make sure I didn't screw anything up with that reload. So we know that when we press the number keys, we're getting these different things to show up, and we're like, all right, let's try to look for where that's happening, right? So instinctively, the first thing you're going to do is try to look for those string literals, right? So let's say that it's been a long time since I've done C, so I look for the numbers in double quotes, right? Because I don't know what the fuck I'm doing, and I think they're strings instead of chars, right? So we do a find in files, and we do a find all, and we see there's only one hit. There's only one hit, okay? And then we see number 4, and we see, oh, there's this like a keyboard listener thing, native keyword stuff. So This could send us on a wild goose chase if we look at this. Actually, this will eventually lead us to where we need to be. But we could also, if we're lucky and we pay attention to this and we kind of remember what that was about, we could grab onto the bed thing, right? If we grab onto the bed and we look for where bed 004 is, and we do a find in files, well, break bed isn't a thing, so that's not going to work now, is it? So find in files, find all. And then we see, oh, here's some interesting, there's a whole bunch of results. Here's what we were previously looking at. And then there's a shader slot 4 available. And so there's some options here. We see key bindings here, and we also see frag bed, right? And they're all things that we want to look at, right? This is where the actual shader switching is happening. And then if we want to look at the overall bindings, right, we can open the overall bindings and see like the keyboard bindings. So we might want a little comment here. I don't know. These keys control which sub editor is active. With control active. It also controls which editor Actually, I'm kind of annoyed when I read documentation and somebody does an etc. without repeating stuff first, so that there's no actual pattern, etc. So this is getting kind of verbose, and maybe eventually we'll want to offboard this, but as long as it's not cluttering stuff up to where it's like, this is way too much stuff, we'll kind of keep it in here for now, right? We can always offboard it later, but we want to write all our comments. A lot of the comments we want to write them inline, and then if we feel like things need to be cleaned up, then we'll offboard those comments to documentation later. So yeah, I think that's good to where like we have designed it to where we can find where things are coming from, right? The idea is we added another piece to the code, and we don't want that other piece to make it even harder to figure out what the hell is going on, right? We actually want the addition of that extra piece to actually make it easier to know what's going on, because we have this centralized place where we can look at the different keyboard bindings and be like, oh, do we want to find the places where the fragment stuff is happening, or the frag bed stuff is happening? Well, we can look at these things and we'll find out where that's happening. We want to find where the Paint 5D stuff is happening. We can look at these bindings and we're going to find out where that's happening in the code, right? So we want to design the code so that it is it's just easy to latch onto things and find what we're looking for. So code is just about connecting the dots. That's all we're doing is connecting the dots. A friend of mine from school once said that you want to think of yourself as a steward of the code, right? You're trying to like show people around and be a guide. And so when you're writing the code, you want to think in terms of being a guide, where you want to like make the code structured in such a way that it's just easy to find your way around. Because honestly, that is the hardest part. The hardest part is finding your way around this stuff as it gets bigger and bigger and bigger. So hopefully, as we get bigger and bigger and bigger, we can keep on organizing it into a way where it's easy to find our way around, right? And we also want to be able to make it easily subdividable, right? So if this ends up, let's say, imagine that this ends up being like 1 million different files. So that would be ridiculous, but let's exaggerate, say 1 million different files. Well, if everything is completely linear, then that benefit of knowing that, oh, this cannot possibly reference the 6056th module because it's number 13 and it comes before that, right? So this allows us to conceptually kind of like isolate what we should look at and what we shouldn't look at like really easily, right? Everything is just very nicely organized. I like it. So now let's actually look at our agendas, because we got that stub in. And actually, before we look at our agenda, let's do a git bash here, and let's commit that change. So git status, git commit dash am, keybind, fragbed uses keybind. All right, that is what we did. And oh yeah, okay, yeah, I got ya. Git status. Keyboard bindings, keybind, centralized keyboard bindings. So the function of keybind is centralized keyboard bindings reference, right? It's just a centralized place where you can, if we want to figure out what's happening with the keys, we can look at that one spot and we know what's happening. So I think I'm following kind of a data-oriented design here, because there's that saying, what is it? Show me your code and I'll have no clue what you're doing. Show me your tables and I won't need to see your code. So we've created basically a big table called keybind right here, and so we don't need to see the code to know what's happening, because we can just be like, oh, so here's the keyboard bindings for the fragment shader, here's the keyboard bindings for these different behaviors, right? And then as long as the code is working how it's supposed to work and it's functioning, we don't actually need to see that code. We just can look at this and we know what the behavior should be, right? And actually, show me your tables. Show me your code. I want to see if I can actually find that quote right now. Actually, let's open up, let's do this together. So I think this might be the thing. This could be the wrong thing. We'll turn on the sound here for a second. Okay, HTMIC.
I just wanted to make an observation. You said something about how this is not a new problem, not a new thing. Fred Brooks said a long time ago, show me your code, I won't know what you're doing. Show me your tables, which is COBOL speak for how you organize your data. I won't need to see your code.
Yeah, sure.
So,
if I know what the input, I know what the output is, there's only so many ways I can get between them. Yes, this is not news, right? Absolutely.
thanks.
All right, so this guy, that's all I wanted to say. I really like that quote. So Mike Action, Data Orient Design, and C++. This is definitely good to reference. So you know what I'm going to do? I'm going to make a little tiny URL here. And I'm going to go to www.tinyurl.com. And we're going to call this Show Me Your Tables, right? So show me your tables. Let's see if we can get that. Show me your tables. Make tiny URL. Bam! We got it. So we got a little tiny URL. Because I don't anticipate anyone's gonna be able to memorize that whole thing there. And that way, you know, if you want to take a look at that video, you can take that tiny URL, tinyurl.com/show me your tables, and you'll be able to get there, right? Show me your tables tiny URL. Your tables. Show me. So I'm just making some notes here. So over in my notes, I just want to make some notes of that. So me your, try, show me your, paste line, and if we do show me your, hopefully we don't get anything non-safe for work. Show me your. Okay. Try, show me your tables. Okay. And then over here, we'll just make the underscored version of that. And then also here, show me your. We'll make an underscored version of that so we can go over here. And then, you know, why not put it in here like that? And then me your, right? Okay. So we have reference for that. And I'm going to take that and I'm going to put it in my little shortcut list. And now I have that at my fingertips even faster than I had it before, right? So I just like that quote, and I thought it was kind of relevant to what we're doing, so I wanted to share that. So I'm gonna keep on keeping on going here. So it looks like, I don't know how I did that. Okay. So I can close this, and actually I want to make sure it works. Let's make sure it works. tinyurl.com/show me your tables. I'm going to close this. I'm going to open up a new tab, paste tinyurl.com/show-me-your-tables. Alright, that's some good stuff. That's some good stuff. I'm happy. So let's, do I need this browser window open? Oh crap, wasn't I using this for Twitch? Let me go back to my Twitch dashboard, because if somebody was accidentally trying to talk to me, even though, like, I don't have any followers, but if somebody was saying hi, I did not see it, so, no viewers, so we're good. So maybe I shouldn't keep that open, because it's just gonna be like, oh man, I don't have any viewers, who am I talking to? So let's keep on going here, and let's not worry about no viewers. Let's kind of like talk as if there were people, and then once upon a time, maybe there will be people. I guess my audience is myself, right? I'm just explaining things better to myself and kind of crystallizing what I'm doing here. So I want to take a look at our agenda screen here. And the keybind, fragment key listener should use keybind. Is that true? That is true. So we've done number 6. And then Taudepo must re-init every time our editor is switched. We actually have to get that working. So let's edit this. So we're going to go into the properties, and I don't know why everything else is unlocked here, so I'm going to lock down everything here. So yeah, let's edit this. So properties, number 6 we are done with, so let's just cross that off the list. And okay, good. So Taudepo must reinit every time our editor is switched. Okay, so let's figure that out. Let's close everything to give ourselves a clear headspace here. Or yeah, let's close everything. And the first thing I want to do is I want to look up Taudepo, and we want to look at the function code. And the first thing we're going to do is we're going to hope that the initializer for this is idempotent, right? If it's not, then oh, well, we have some problems, right? But we want to make the initializer idempotent. We don't want like a reinitializer. We just want like an init, right? So we have this init thing here, and then we know in the function file for like the main function file. So right now we're looking at functions and functions, but this is what we need to look at. We have kind of this keyboard listener here, and we need to think about, do we really want, like, I don't really want, like, all this stuff to be, like, inside of handle input, right? I think that's just going to make things kind of like, I don't know. I would like not to just shove everything into handle input. So let's look at what we have here. And we have this dex eddy, right? So this index of the currently active editor. And we also have next eddy, right? So what I think is we can take this and let's think about it. Okay, you know what we're gonna do? Let's actually, since this only has to re-init if the editor has changed, I think what we need is, we need like a initialized with variable. So what we could do is we could do like, if AAC 2020 Taudepo initted with last so we're gonna initialize, like, after we choose this, right? After we choose the editor in focus, then we're gonna initialize this. So we're gonna say that initted with is not equal to this. Then I really don't like early exiting like this. Well, actually, you know what we'll do? We'll do, so we'll take this equals, so flat is better than nested, right? So let's take this editor index, the active editor index, and what editor index is active track. We need to know when fragment shader changes, dex eddy, the Taudepo must rewire up its texture samplers. Alright, so we can do this, and then this code, right, it's better to be flat than nested, so we can take this and actually put it somewhere outside of here, right? We can put it in like the game loop. So let's look at where the handle input is happening, and then we see that we have a game loop, right? So what we could do in game loop is we could actually add it here. So we could take this logic here and so I think we have graphics update tick. Is this actually being called from anywhere? Hold on. Oh, okay, so it's not anymore because it's like in here like that. So let's not, So I think that there's a lot of logic in here, so I just don't think that, I think it makes sense to, like I know how I kind of took graphics update loop, I took the function for graphics update tick and I kind of like threw it in here like this. So do we want to, we could actually do a loop tick like that, like if that's the way, if that's the structure that we're going for, then that maybe this shouldn't go in the game loop, maybe this should go in, so we have, and also if we did that, we would easily be able to see where everything is being used, right? Because then the knitted width is going to be referenced exact. So what we could do is we could do the update tick needs to update tick. Well, actually, it should be like a loop tick, right? Everything should be called loop tick for consistency. Yeah, loop tick. So the idea of calling it loop tick means that it's not a loop itself, but that it's a function that's supposed to be called inside of a loop, right? And let's see, do we even have documentation on that? Like, I know I use loop tick, but have I used it anywhere? So loop tick. So if I type loop tick like that, we don't get any documentation. Okay, so let's actually make some documentation for what loop tick is all about, right? And then let's also write it differently, like in case maybe we have loop tick somewhere in here, but it's camel case, right? And we don't have that either. So we just want this so we we can find reference for what the hell we mean by loop tick, right? Because loop tick is not like it's not a standard like thing. It's not a standard convention in code bases. It's just a thing I made up. I'm sure that it's not unique. I'm sure plenty of other people do it this way, but I don't know what their terminology is for it, so I just call it a tick, right? Because a loop, or maybe you could call it a cycle function, I don't know, but I call it a tick because I'm thinking that every time you go through the function, one iteration, that's a tick. So tick, 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 like a clock, right? Loop tick. A sum function loop tick is a function that is meant to be called within the body of a loop. Typically, a game loop, 2, a render loop. Okay, so that's what loop tick is. It's just a function that should be called inside the body of a loop. And typically, it's a game loop or a render loop, okay? So now that we've kind of documented that, we can keep on going over here. And loop tick is going to be able to reinitialize the system, and that's why it needs to be below, because loop tick is going to call the function up here. And we're going to take this code that I thought, you know, could go here, because it doesn't really belong there, because it's more like rendering update stuff. And so in the other loop ticks, right, so if we look at the other loop ticks, we probably have a common signature of like returning or taking like a unsigned 32-bit integer and then returning unsigned 32-bit integer. So we're going to stick with that formula just for consistency. So U32 AAC 2020 Taudepo and loop tick, right? And it's going to take a U32 called U32. And if the U32 something something, we're just going to do reserved for future use, right? Okay. And at the bottom of the function, we're going to say return 0x00, right? We're not going to actually return anything meaningful. We'll just return a 0. So, does this belong in graphics update tick? And the answer is no, right? And we just got rid of that. So this initted with variable, we're going to check the active editor, right, that we last initted with, and if these don't match, then we're going to initialize again, right? And the initted with is going to update the editor that we initialized with, right? So with that, all we got to do is do a AAC 2020 Taudepo and init. So and we can also look at our sprint, so our agenda screen here. So part of sprint number 003, video IID 0041. Okay, so I'm actually making a note in my agenda. Like how long have you been recording? So at 2 hours, 2 hours 55. Okay. Let's go back to our code here. So I just made a note here. I'm going to actually make a note of exactly when this happened in the video, right? So as we're describing things, why not just kind of document our thought process, right? Like, it wouldn't be great to like go back and be like, what the hell was I thinking when I did this? So we'll actually make the integer ID of the video, which is 0041, and the recording date 12/13. And it's at 2 hours and 15 minutes is where we are, and be like, every time we switch editors, a new fragment shader is loaded. Code. Yeah. So now we have like a nice little comment in the source code that links to the video itself, right? And I think that'll be helpful. And the idea is like, you know, I don't know, no one's watching this, but what I can do to where I still get a benefit out of doing this is I can meticulously kind of document what I'm doing, and we have videos of what we were doing, and so we can actually go back and we can check those videos and be like, what the hell was I thinking? And then we can actually look at the source code, compare with the video archive of the notes, and then we know what we're doing. And also, if I document this very, very well, then eventually, let's say I have to compete with another code base that does something similar, right? Well, if I am very pristine about how I write my code base and my code base's quality, then other people will want to use my system, right? Because the two systems do the same thing, but one code base is a complete mess and the other one is just nice and pristine, right? Or even if they don't like the way I wrote the code base, they're like, man, this is really well documented, right? Really well structured, very approachable, because somebody ranted about how the whole thing works for like hours and hours and hours, right? So, Taudepo loop tick. And then right here we have these graphics update tick, right? So, bassoonif doesn't actually exist anymore. We removed that a long time ago. And actually, since we did remove it, if you really want to keep it here for reference, like we just absolutely want to know about it, it should have, I should use my convention of using dashes like that, or a little minus symbol by the comment character, which creates the comment in red. So you notice that my comments have more syntax highlighting than my code, right? It's like the code is just very plain, no syntax highlighting, and then and then the comments have different colors, right? So the reason I do that is just I want to know what to focus on, and I don't want the IntelliSense telling me what to focus on. I'll decide what I should focus on, right? I don't want to paint every file with the same brush, right? This is more of an art. So we're going to do Taudepo and loop tick and then 0x00. So we still have some more stuff to do. So this initted with doesn't actually exist anywhere, right? So let's go into the data and look at lib and look at Taudepo and look at the data. We have this nice little diagram. Oh, that's awesome. And some stuff. Okay, so we got like a library struct, and then some defines so that I'm gonna keep the initted with outside of the library struct. It was kind of like an afterthought and I don't see any reason for it to actually be in here. Because this is very meticulously organized and has a very kind of consistent, it has a very consistent regular pattern, right? This library struct, and we're adding a piece of irregular data, so I think we should just kind of like put it in a misc section. I'm just going to throw it in a misc section. Misc. Right? And then we can throw it here. And I think this should be a, I don't know what I originally used for dex eddy. I think it's probably it might be a U32. So let's look at ceditor, C-editor, and let's look at the data. And we see that it's a U32. And that's probably because I have the intention of, maybe in the future, packing it onto a, what do you call it? Like I might actually want to store this variable into texture memory eventually. And so anything I want, I think I might want to eventually put into texture memory, like load as a texture as uniform. I want it to be an unsigned 32-bit integer, or a collection of unsigned 32-bit integers, because I'm using an unsigned integer texture. Now we could encode and decode integer numbers in an unsigned integer, but now we're just adding that. That to me is too complicated. That seems complicated and error prone. I think that to keep things simple, let's just try to all the math that needs to be communicated between the GPU and the CPU, let's just try to keep it to unsigned integers, right? Now, what about floating point? Well, we're going to try not to do floating point. We're going to try to keep everything with discrete math. So, knitted width, and the knitted width index right now is nothing, right? It hasn't been knitted with anything, so we should try to use like a suitable maximum value. It's unsigned, so easily we can just go FF, 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 and FF. And since we only have like 9 slots, I would say that that max value is plenty higher than 9, and we won't have to worry about it, right? So, so this is just saying that it's not set, because 0 is an index that it could be initialized with, possibly. Well, not really, because 0 is yourself, kind of. But yeah, I think this would be better. And yeah, so we're using that. We got the loop tick, and now we have to go into F macros. But before we go into F macros, well, we already added it right here. We already added the F macros loop tick here. So let's just go in and look at our F macros. And F macros top and bottom. So the reason why we have this thing called F macros for function macros is because remember how we can subdivide the project and slice it and dice it and recompile it, right? So the way we're going to make this kind of like this main function file a lot cleaner is, instead of like wrapping this in a if this is defined, run this function, 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 instead of having to do all that meticulous wrapping and to keep everything kind of as streamlined as possible in here, we're going to offboard some of that dirty ugliness to the F macros file here. So we have, we should have a loop tick, so yeah, are these all loop tick? So we're kind of keeping this pattern of, looking at the exact number of the system when we're defining the loop tick. I don't know if that's the best way to do this, but I like the extra redundancy. Why is there no... Well, iKeybox doesn't have a loop tick, right? But I do like that it's like this, it's not too bad. Let's just use it because it works. And also, auto-generating stuff actually makes me nervous as hell, because then I have to delete everything and regenerate it and hope to God that I've been keeping good records. So I'm not sure if I really like the auto-generated stuff, right? Because it also relies on having a specific tool to find and replace and cut and paste. And yes, I have that, but other people don't. So let's look at, not that. So looking at our library chain, right, we're concerned with the Taudepo, right? So this guy right here. So this is way near the end, right? So all these here, we can just paste it down here, right? So we could take Graquad and we could paste it here. And then take these instances where it says Graquad and just go Taudepo, right? So anywhere we see that, we can just go paste it over. And then we also have to change these numbers, right? So these numbers right here are going to need to change. So anywhere we see Graquad, we'll just replace with Taudepo, 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 and Taudepo. Okay. So this system is number 20 currently, so we're just going to put a 20 there and a 20 here. And we can review what this logic actually does, right? So, right, so if it is defined, right, so greater than equal to 1, if we actually define it, it's going to be greater than equal to 1. So this include is always defined, but it's going to be 0 if we're not actually including it. And the reason why I kind of do that instead of defining it or not defining it is because I like to be very explicit about what I do and what I don't do. So that is why this include variable, it always exists, but if we're not including anything, it's going to be set to 0. So we have one external wrapper here to make sure that it actually exists. Then we have a static exert for some just extra protection. We could totally just remove this and it would still work fine. But the extra redundancy I like, gives more rigidity to the code. So we're just going to take the actual function and just replace it with fmacros Taudepo looptick. So to make sure that the function name doesn't get like way too long, right, we just take off the namespace of the library and we just put fmacros in front of it, right? So when I have a macro that's not defined in the same file that it's used, I want the word macro or at least mac in the name of that macro so that I can identify it's a macro, because I think the worst thing about macros is not knowing that they're macros, right? Like when you know it's a macro, everything's good. It's when you don't know it's a macro and you're running it in your code base and you get weird things happening because you didn't know it was a macro and weird stuff is happening, right? So let's actually try to consolidate this a bit. So I think we can kind of do that, and that's like, I don't think, like, I do want a little bit of white space here. Like, I think that is like way too busy. I like look at that and I don't know where to look. So we need a little bit of room to breathe, but we don't need as much as we were using, right? We just need we have kind of like a double spacing kind of effect going here, and I think that really works. So let's take fmacros looptick right here, and let's go into our function file and just control F for it, make absolutely sure that everything is spelled correctly, and that looks correct. Okay, so if we review the function, the looptick function, looptick, big comment telling us why the hell we're doing this, initted with, so just a little guard, and if these numbers don't match, we're going to call init again, right? And let's highlight this really quick. So we're going to highlight this so we can, actually we're going to remove all highlighting first, and then we're going to highlight it again. And then if we go into the init function, we should see that blue thing showing up again, right? So we're going to set it to the index editor of the editor, right? So let's highlight that a different color. So we got these two colors here. And we see we're setting them equal to each other once we go into init. And where we're calling init, we are comparing them to see if they are not equal to each other, right? So that is good. And I think that I would like to have like some type of information message telling me that I am reinitializing this system. So I see I kind of cut down on having too many logging functions because those are getting out of hand. So in here, I think I just have like two functions. I have a logging function and a halting function, which I think is all you really need. I got way too granular before. So we're going to take this and we're going to just make a little logging function. And yeah, there's a silence in front of it, so that's good. And right here, we're just going to make a note that we are reinitializing so that we can see that in the console. So we'll just say this, and we'll say re-initting Taudepo, right? And this is kind of like really ugly, so we're going to replace that with a log macro and go define log. And then also we're missing the, now that we're here, I see that we're missing the U32, so define U32. And then down here, we're going to undefine them. So we can just copy this, and then we can delete the end, and then we can change this to an undef, add an extra space so it still lines up. And I think we're good there. We got the little log. And now this log message, because it's a generic log message that is designed to be used with like any other, with other types, I kind of like wanted to keep it, I wanted to kind of, some of the simplification came with some extra weirdness, I guess. But if we look at the logging function, it takes two parameters, a format string and then a pointer to some data. So if we don't want to actually use any extra data, like the format string doesn't have anything in it, then we just want to give it a void pointer. So we're going to take void pointer, right, and we're going to cast 0 to a void pointer. Now this will actually work if we don't have to do it this way. We can actually just give it 0 and that will also work, but it's nice to be kind of explicit and let us know what we're doing, right? Because if we just do 0, it might look like we're trying to like print 0, but we forgot the %d in the string, so it can look a little bit ambiguous. So if we have the room, if we have the column space to write it out all long-handed, we should do it this way. If we're like coming up next to this edge, then I'm just gonna be like, fuck it, we're just gonna put a 0 there because we don't got room to be super verbose. But when we have room to be verbose, when we can afford to be verbose, we're gonna be verbose, okay? So I think that looks good. Now, oh no, well, let's just find out. Let's just see what happens, right? So, unknown type name U32. So I forgot to, so this initted with here, I forgot to add it in the other file. So in our data file, right here, we gotta like add define U32 at the top of the section, and then we'll do undef U32 here as well. And then also the misc section, I didn't even finish the pattern, right? So I want to, you know, it's just an OCD thing of mine where, you know, a lot of times when I read code, I see like these different sections labeled out, and, you know, sometimes they try to cluster things by, you know, using the spacing. But a lot of times I see these comments of like what's supposed to happen, and I'm like, I don't know. I see where the comment starts, but I do not know where the comment ends, and that annoys the hell out of me. So I always want to know where the comment starts, and I want to know where the comment ends when I'm defining like a region of code, right? So that's just a thing that really gets to me. I just don't want to make, I want to make as few assumptions as possible. Now, if it's just your code and you have another standard way to communicate this, where you just label the top of the section but you don't label the bottom here, and you just remove this, and you just understand that once this new section starts, that the start of this section implies the end of this section, and you're consistent about that, then it's not a problem. But if someone else is looking at your code, how can they be sure about that assumption, right? And I guess we're still making an assumption here, but I think it's a little bit more in your face, right? I just want to be more explicit, if that makes sense. So AAC 2020 Taudepo init. Too few arguments to a function Taudepo init. Okay, so I believe that's because, you know, we decided that all the initializer functions, we would just have like that U32 for reserved for future use is also what we're doing with the init. Yes, so that is what you're missing there. So let's give that a run, see if that fixed it, and if that fixes it, pedantic. Let's remove that. So I have some habits that the strict C compiler does not like, and I'd rather just do it the way the strict compilation wants it to be done than to turn off more strict. I want the compiler to be as strict as possible, right? So if I have some type of quirk in my style that's triggering the compiler warnings, I'm going to change that style. There is an exception to that, and it's called Golang, which I no longer use because it's so authoritarian in the way it wants to tell me how to write my code, and I'm like, fuck you. Like, I don't care if I put everything on one line. If I got semicolons between all my statements, the damn thing should still run. Like, I'm the human being here. I will decide holistically if the code looks good or not. Don't give me some basic heuristic that you're going to blindly make the compiler follow and make me follow. I just fuck that shit. So anyways, so it looks like we're good here where it's still working. I need to check the console. So I'm actually going to move this over here, and then we're going to look at the console. And we're going to just see, so we have, so it says no texture sampler Taudepo, right? And that actually makes sense because in these shaders, we haven't set up the texture sampler for Taudepo. Now, the other thing, have we set up a texture sampler in anything? Taudepo info any instance. No texture sampler Taudepo. Okay, so that's fine. Ooh, nice. That is fine with the way we're doing things, because the Paint.5D shader doesn't have that texture sampler embedded into it yet. So actually what we need to do is we need to put the sampler uniform into the Paint.5D shader source code, which is a really simple task, but I do want to make a note of it in my agenda screen. So we actually got 7 taken care of. So we're going to go into the properties, and I'm going to rewrite this really quick. So I'm going to take all this, I'm going to put it into a better editor so that I can kind of see what I'm doing. And Taudepo must re-init, and that was 7. So we're going to make a new 8. 8, put uniform sampler, sampler Taudepo into Paint.5D frag shader. 8, 9, 10, 11, 12. Okay, so fix that up, and I'll paste the changes into here. Okay, so now we've done Taudepo must re-init every time editors switch, and we need to put uniform sampler Taudepo into Paint.5D frag shader. So any subsystem shader needs access to Taudepo, because those are like going to be the shared uniforms between all of the subsystems. And boy, we are running out of room here. So let's do that. So let's go back to our coding screen. Oh look, I have one person looking. Is that myself or is that my girlfriend? Let's say hello in the chat and see if anyone is there. So anyways, let's look at the agenda screen because I obviously can't focus sometimes. So agenda screen. Put uniform sampler. Okay, yeah. So we're gonna open up the frag shader for Paint.5D. So let's to focus, let's close everything, right? So let's close it all. Get a nice clean blank slate, and we want to, in the library, we're going to look at the Paint.5D shaders, and look, we got Paint.5D default shaders right there. So anytime, right, we want everything that's top level, any top level systems to be just dumped directly in here, right? We don't want to like branch it out and categorize it and all that shit, because that just makes it harder to have an inventory of everything that's there. But whenever one of these systems has like more than 2 files associated with it, when a system has more than just a .d and a .f file, then I actually want to make a folder for it, right? So Paint.5D has a folder for it because it has a shader code, and I wanted to isolate that shader code into its own file because it's well, it can be quite long, and right, so it made sense to just isolate this unit, right? Because there's a lot of times when I'm just going to want to look at that code in isolation. So let's alter this once we get project running again. I'm just looking at the vital to do here, and we are kind of altering it as we go. But we see sampler 2D, and then we see uniform sampler paint 5D. And then we just want to add in Taudepo, right? So uniform vec, not vec3, use sampler 2D and Taudepo, right? And right, and so I'm not memorizing anything, right? When I'm doing this, I'm not like, how do I know that it's called this, right? How do I know that? And I know it's called this is just because I'm being consistent. I'm being very consistent, right? So the subsystem is called Paint 5D, therefore its associated texture memory sampler is also called Paint 5D. Same thing with Taudepo. Since the system name is Taudepo, then its texture sampler is also going to be called Taudepo, right? So just have that consistency. So the more consistent you are, the less you have to remember. So, hey, going to bed, take a small break. Okay. All right. I'll set my timer. Okay. Okay, I gotta take a break. So let's see. Let's actually open up our. Let's get this. Let's get a timer up. So, red timer. Open that up, and let's we'll set that, and then we actually got to set this to the break time screen. So let's do.
Another failure. Back to the old drawing board, I guess.
I must use this power only for good.
Professor Gill, thank God I found you! There's trouble down at the Cobra Hut! Some crazy guy in his underwear is unleashing brutal carnage! He must be stopped! Well, to be honest, I don't think...
I can neutralize him.
These tacos suck!
Stop! Away, Fluffy!
Oh, he's so cute! Here, let me pay for the damage.
It's okay.
I keep on having this reoccurring dream where Toby Maguire watches me eat cream. Toby asks me, can he have the rest? Then he proceeds to pour it on his chest. Atop the tallest building of a cityscape scene suspended from a construction beam. He stares into my soul, watching me as I lick the bowl. Now he's naked in my grandma's bath. I start to cry, but he just laughs, gazing hungrily into my eyes. He removes the hair from his inner thighs. I wake from my dream. I'm aroused and sweaty. I head to the fridge to get a big bowl ready. As I lick and work the spoon, I feel a presence in the room. Hi, Toby. Hi, can I have some of that cream? Sure, here you go. Thanks a lot. Anytime, Toby.
This video is sponsored by CuriosityStream. Use the link in the description to watch.
Alright, so let's get back into it. So we're talking about getting this shader sampler in here. And hold on. I just need I'm updating some of my shortcuts really quick, because I was in the middle of that. Okay, anyways, so adding this shader sampler, it should be just as simple as that. And if we give this a run, what we're going to expect is that now when we run the, when we run the project, it's still not going to work because we're going to load that shader from disk rather than from the source code. So I forgot about that, but let's actually look and see what happens. So yeah, we see that no texture sampler is getting echoed still. But if we go into the not the documentation, what am I thinking? If we go into the mod folder, and we delete the first shader, right? And then we rerun this, it's going to have to grab that shader from the executable, and it'll grab the newest version of the shader from the executable, right? So now, if we look at this, and we're going to hope that that when we hit number 1, it says something different, or crashes, or something, right? We want some type of different behavior. So right now we see no texture sampler Taudepo. So somewhere we have greatly fucked up here. So we got to think about why is this screwed up? What's going wrong here? Because this P5D should have a texture sampler, right? And when we go over to these other Well, we already know that we have a texture sampler for Paint.5D because, well, we can see the texture, right? We're sampling it. So now the question is, what have we done differently in Taudepo to make it so that we're not seeing the texture sampler, even though we know that it's there, right? So let's close. Let's Control C here. So that's kind of like, what the hell? I thought we had this in the bag, right? So Taudepo, let's Control H and let's look for find in files, and let's match the case this time. So we're gonna match the whole. We're gonna match the case, and we're just gonna look for Taudepo, and we're gonna assume that we're gonna find it in pixname. And we can see it in the shader code here, and Taudepo.f, pixload, pixname. So I see that in pixname.d we have like this little comment, and that's because we had to Taudepo, right? We had to kind of like inject it like this because of the constraints of the code. So I really don't know what's going on. Let's look at Taudepo.f and look at the log message. So, actually, while we're here, getting sidetracked, but really quick, we need to open up the silence because we added something, did we not? It doesn't really have any bearing on the code, but let's take care of that while we're here. So, so right now, we added a right between iMouseBlock and C editor, right? We added U08, and it's not going to be used anywhere, but let's keep it, right, for consistency. Keybind, right? So we have this key. Actually, well, we might actually need keybind. Well, no, because it's data only, so it doesn't really have, it doesn't really talk, but we want to just put everything in there for consistency, right? And then down here, right, it's right after iMouseBox, right? So we're going to go D like that, and then we're going to do keybinding, right? And it doesn't actually talk, but let's turn it on because it's a new system. So let's just keep the habit of when we're adding in new systems that we want to make sure that the echoing is on for being associated with that system. So let's give it a run. Just make sure that the simple little change didn't completely screw with the code. I don't think it should have, but I constantly surprise myself at my ability to make really stupid mistakes. So. Okay, so we're good there. So now the question is, no texture sampler, Paint.5D, right? And then when we change here, we're seeing no texture sampler, Taudepo, and no texture sampler, Taudepo, Paint.5D. So what I'm doing is I'm just trying to see if so I don't know why it's not seeing that texture sampler. It could be that the shader is getting loaded and then we are trying to look it up. So if we look in the function file, we can actually kind of get an idea if that's what is happening. So in the main function file, so where's our F file here? So in our main function file here, we should have the F macros something or other. F macros loop tick here. And is this happening after the input? And it is happening. It's happening before the handle input, right? So so that's going to create a problem if we're trying to load that shader, and then we're gonna, if this loads the new shader, and then the loop tick comes next, then that's out of sync. But does that really matter? Because, yeah, it's going to lag behind by one. It's going to lag behind by 1 frame, but... Oh, it's not going to match. It's not going to match. So, like, okay. So we initialize this. And we have... So let's say we're not at paint 5D, and it gets initialized, right? We're looping, we're looping, we're looping, and then eventually right here, we decide to change to paint 5D. We try to change to paint 5D, that initted with flag, though, should have changed, right? So if we look at the initted with flag, right, in Taudepo, right, so this knitted flag would change, right? Yeah, because we're gonna log the, we're gonna change what flag it was knitted with. But I feel like we're lagging behind, so... I think it's out of sync, though. I don't think that matters. So we should probably make absolutely sure that that doesn't matter, right? So let's make absolutely sure and just shuffle this around really quick. Because I can kind of see how that might matter. I don't think it should. But let's test that assumption, right? Because if this actually makes it work, then we gotta rethink our lives and think about what we're doing here. But I don't think this is gonna fix it. But so we go here now. No texture sampler Taudepo. No texture sampler Taudepo. Okay, so that's not the problem, and that's good. So we know that it's not about that. So we can keep our nice grouping. We can keep that grouping, and it's not going to be a problem. We can put this back here. It's fine to be grouped here. It is lagging behind by 1 frame because we kind of handle the input and do the game loop, and then it updates the frame after. So it lags behind by 1 frame, but that's still fine. Okay, so let's actually look into this code here, right? So we know that the thing we're looking for is the phrase no texture sampler, right? And we're like, well, why can't we see a texture sampler? So has, right? We have this has, and it looks like we're has check. And if it doesn't have this has, it looks like that's an error. Dat.sam has, sampler has. So I don't know what's going on here. This is just to see if the flags agree with each other. So this has check, pixload has sampler. So something in pixload has sampler is not working, right? It's like it's saying we don't have a sampler for you in the currently loaded shader. So we need to know why that is. So let's see. Why does it not think that there is a shader when a sampler? Why does it not think there is a sampler for that, right? Because, you know, we're doing what we should be doing. It's in the source code. What's up with that? So, Pixload has sampler, and so the pix name here. And so this is pretty straightforward. I think that makes sense. Right? We're gonna look at the program, and now does the program change when we like recompile? Are we like getting another program ID? I don't think so, because if that was the case, then the pixel stuff wouldn't work either. So yeah, I'm not sure about that. Let's look in our mod folder and make sure that the copied over thing actually has the sampler. So Taudepo right there, yep. So I don't know how it's like in there, but it's not like. Oh, you know what? I know why. It's getting optimized out. It's getting optimized out. So this is like, man, that would be infuriating. Oh god, that's infuriating. So let's make a note here. Well, okay, let's make sure that I'm right there before I be like, oh, it's being optimized out, we're done, right? So it's only referenced here, so the compiler is being like, oh, you're not referencing us? Well then, fuck you, right? So, what we need is kind of like, a I don't know, let's just write some code here and try to... Let's write some code that kind of uses this somehow. Let's say that, you know, if the fragment coordinate, so the GL frag chord here, minus 0.5. So if GL frag chord dot x minus 0.5 is less than 512.0, and GFC dot y minus 0.5 is less than 512.0. So right, if the frag chord is like in the area where that texture memory is, then we're gonna like do a texture sample from it, a little texel fetch, and it looks like all we need is to do like a texel fetch. Really, is it texel fetch like that? I thought it was texel underscore fetch. Whatever, that's the way it is, I guess. So texel fetch. And we need the actual thing to sample, so Taudepo. And then we need the texel coordinates, so we're going to do IVEC 2 GFC.x minus 0.5, GFC.y minus 0.5. And then we also need the level of detail. The level of detail is just going to be 0. And can we just use a straight up 0, or we gotta cast it? Int 0. We might as well cast it just in case. Int 0. Right. So let's make a note of this. Texel fetch, and we want to just set frag color equal to that texel fetch. So frag color equals texel fetch. And this is ugly as hell, but so we could actually just do GFC dot xy minus 0.5, I think. that'll take the x and y and minus 0.5. And I think I can be shorthand but slightly explicit by doing .xy, so that we know it's not just two scalars, that it's actually a vector and a scalar we're doing this with. And then now we have enough room to where we could say like sampler pixel this is LOD, level of detail. Okay, so that looks good to me. Let's look at our bracket balancing and all that. Okay, so that looks good. That looks like, I think that'll work. Now, if it doesn't work, we'll be met with a syntax error, state in our shader. We'll see like syn error, so it's not a big deal if we have a syntax error. It's not going to crash the program. But let's give that a shot and see if that... oh, actually, we still have to delete it from the mod folder. So delete that and just give it a run and see if... what we get, right? So we're gonna go over to this one now, and oh boy, oh boys, so something happened, that's for sure. So I'm going to just take a guess that that texture slot 0 probably got triggered again, right? Because we wanted to make sure that we never use texture slot 0. And so I'm going to guess that in pixload, it was looking for texture slot 0, and it's like, fuck you, you can't use texture slot 0. Oh, actually, it's not that. It is, I added like a little extra redundancy here for some air checking, and I'm just being kind of extra redundant here, making sure that the pixel name should be one of these pre-selected values, right? And that's fine. Like, we can keep this rigidity. I'm fine with keeping this kind of like extra rigid stuff. And we'll call it Taudepo, not equal to 0. And, I mean, the whatever message is fine. It's like, you don't know what the hell it means, but you can find where it came from, right? Like, if we do, it would be nice to have a little more room here, though. So where is this coming from? So we see we already have air right here defined. And so we can already just be like, boom, air, right? And we don't have to change anything. We can keep it shorter. And then we can also say, well, now we've changed it. We don't know what the original time was, so we can change it to the 13th. And then we can go 04:05 a.m., and then we can be like, whatever, right? Like that. Bad selection, right? Instead of calling it whatever, we could be like bad selection. So that's a little bit better, and so let's give it a run. So it was we made some progress, right? Because it appears that the shader must have been the shader must have not had a syntax error, because it was able to pick up that shader uniform and be like, I don't recognize that shader uniform. That's kind of what happened, right? So if we go here and we go to Paint 5D, and we have another different error. We have text slot never 0 neg, okay? So that is also one of the errors I put in the code to be like, never use texture slot 0, because I was kind of like adamant about that before. But now we can kind of remove that. So if it's less than or equal to 0, we're going to say that so we're going to just say if GPU data text slot is equal to 0, or if we'll do 0 equals, because I just want to make sure that I don't accidentally do something with that, right? So if you're 0 equals GPU data dot text slot, and I would put the comparison on the other side, but I find wrapping my mind around that sometimes doesn't quite work. Because right, if we want to swap this comparison, if we want to take this 0 and put it on the other side, then we have to maintain the direction it points in, right? So instead of less than or equal to, it's going to be 0 greater than or equal to text slot, which is kind of a really weird way of thinking of it. But I mean, it's fine, but it's just it adds a little bit of complexity to understanding the code. It's a little bit too clever. So we're just going to have this kind of wonky formatting so that we can keep this lined up, but keep our Yoda expression here so that we don't accidentally do any assigning, right? So if 0 is equal to the texture slot, okay, and then else, and then right here we're going to say less than 0, so less than 0 now. Changed my mind on 0. So we're going to make a change my mind on 0 comment here. And then in the hashtag comments right here, we'll just make a note that old comment, changed my mind, now using slot 0 for Taudepo. So we'll do like this, and then we'll put this in parentheses. I don't know. Doesn't really matter too much, but so old comment below, and then we can put this in like little stars to kind of like bring attention to what we're talking about right here. And then in the pix load, we'll take this change my mind thing, and we'll be like, oh wait, we actually want to do that as like a little section like this. I decided to use texture slot 0 for Taudepo because we need a common texture to share uniforms that are encoded into the texture itself. Okay, so that's kind of why. Update. Changed my mind on date 2020 12/13, right? Okay. And then we still have this change my mind on 0. This is still within the comments here, right? So we have changed my mind on 0. Yeah, okay, cool. So, so instead of 0 neg, it's never negative, right? Text slot never negative, okay? And do we have like a notification thing? Like if we have an error and we have an OK. If do you have a GPU data in here? What do we got? We got GPU data. Okay, so if strcmp GPU data dot pixnam and then Taudepo equals 0. We're gonna do OK Taudepo is allowed to be 0. Okay. So that is a bit long of a message. Else. Okay, but if otherwise, we're still gonna be a little bit rigid on this. We're gonna allow Taudepo to use texture slot 0, but anything else, we're just gonna say fuck it. Nope, that's probably a mistake, right? All the systems, they can use whatever texture slot they want, depending on what slot they are associated with. But 0 is kind of like special, you know. So otherwise, we're going to do an error. And is it ERR for error this time? Yep, so ERR. So otherwise, error. Only Taudepo can use texture slot 0. Okay, so that is just long enough. Or just short enough, right? And okay. Instead of allowed to, we're just to uses. Taudepo uses texture slot 0. Right. And then we can kind of like condense that a little bit. And that's fine. So Taudepo right here. And we might also want to say like Taudepo. That's just so that we can like do this, right? So now we can see Taudepo there like that. And strcmp with the pixel name and equal to 0. Okay, yeah, so that looks good. That looks good. So we kind of split this apart again. Change my mind on 0. Let's kind of break that apart a bit. Yeah, so else less than 0 equal to 0. Okay, yeah, we're good. I like that extra logic. It's a clunky, but I'd rather be a little bit clunky than pull my hair out trying to find bugs in my code. So let's give this a shot and see if it works. See if it. Oh no! Crash on me again. Why? So improper setup SAMVal. Okay, so we got this OK message, right? So we kind of addressed that because now it says OK Taudepo uses texture slot 0, but then we see this thing that says improper setup SAMVal. And it's probably another one of those damn checks, because I just went all over the place. So if we do find all, and we kind of like look in our files, we can see, oh no, improper setup SAMVal. And I'm going to guarantee almost that we have less than or equal to 0. Yeah, we have improper setup SAMVal. So So for this, we're going to take this comment here, related to old tag, so let's actually kind of put this tag in here as well, because we kind of changed our mind on it, and we just want to be able to see it up here as well. So related to old tag, right? And then we can take change my mind on 0, and we can put this new tag in here. I'm also going to add like a little bit more verbosity to that, and I'm going to add like a little synonym, right? Just because change my mind on 0, 0 could be a lot of different things. So if we have the room to make a more verbose tag, we should probably make like a synonymous tag there. So Now that does make it a little bit hard to figure out where these are referenced, but I don't really want this to be doubly linked, where it's like it has a back reference. I want it to be, when we're looking at the comments, we can get to here, but I don't really want to go from here to the code ever. Now I could see why that you might want to do that one day, but that's very rarely something I would ever want to do. So it's okay to have these two synonyms. So if I really want to go backwards, I got to search for all of this, and then I also have to search for all of this to find all the references. And that's very annoying, but because I'm designing it to funnel into here, not to funnel out, that'll be fine. Okay, so I changed my mind on this, and what we can do is we could just keep the less than or equal to 0, and then we could just say that if GPU data samval, so if 0 equals GPU data samval, and 0 equals strcmp, GPU data pix name, and Taudepo, okay, else I'm gonna say only Taudepo can use slot 0. Okay. And then we'll put that in the comments. So even though I changed my mind on this, we want to make sure that we're not like just saying, oh, texture slot 0 is good for everything. We're just saying that, you know, if it's Taudepo, then we're going to allow it. But if it's anything else, we're not. So, originally, I never wanted to use texture slot 0 for anything, but now I've decided that Taudepo can and must use texture slot 0. All other sub okay, so I made that note there, and then if we go look at this again, okay, it's right there. So, this is a little bit long. You know, we could try to do some macro magic or whatever and clean it up, or we could just kind of like, we could just crunch it together and just be done with it, you know? Part of me is kind of like, S wants to do this, even though that's kind of ugly, but yeah, why not? Define CMP, strcmp, and then we'll just do undef here. Undef CMP, and I'm pretty sure I use CMP somewhere else in here as well, or in a match case. So CMP, oh, I guess that's the only place I used it. I'm gonna use SC for string compare. So SC string compare. So that's a little bit more cluttered, but then we don't have to sacrifice the spacing, right? We can keep it like that. Now the other thing is, do we want Taudepo like right off here on the edge? Or do we want, does it make more sense to like have it over here? I don't know. It doesn't really matter. So over here we need like an OK message. And I don't know what the define for that is, so let's look at OK. So we have error and OK right here. So, you know, we were doing like oh no in here because for some reason we just felt like it. Is that a good idea? I don't know. But if we want to keep that, if we want to keep to that, then let's keep to that absurd pattern we put in there and. Okay. Alright, like if that's how we want to do it, if that's how we want to roll, then okay, we'll roll that way, right? But then we also have to make sure that we do it over here. So undef, okay. And then over here, we can do an okay. Taudepo's SAM val is 0. Okay, so we can just make that note there. That's okay. Now it makes it a little harder to click on, right? Because it has all these things dividing it. But it's an okay message, and when it's something that's okay, it's very rare that we're actually going to want to search for where that's happening. It could happen, but it's usually when it's an error message that we want to grab onto it and find where that's coming from the source code. So yeah, so if we are less than or equal to 0, we're gonna throw an error, but only if we're gonna take a second look here and be like, well, it's less than or equal to 0. Well, is it exactly 0? And if it's exactly 0, is it Taudepo? Because if it's Taudepo, then we're going to allow it, right? Okay, so let's give that a run and see what happens next, and hopefully, eventually, this will just work. GPU data has no pix name. Okay, yeah, so that's just me not spelling things correctly. So I got this whole, like, terse syntax, and I'm like, huh, yeah, let's put an E on the end. No. Okay, so there you go. So pix name, or pixnam, I guess, if you want to pronounce it the way it looks. I don't really care. Okay, moment of truth. Okay, let's procrastinate. Okay, let's press 1. Okay, it crashed. God damn it. So let's see. We got further though. So we see re-initting Taudepo right here. We got the sampler location. The sampler value is 0. Taudepo uses texture slot 0. Okay, Taudepo's sample value is 0. And then fetch 0 or neg sampler value. So boy, we have like a lot of checks to make absolutely sure we're not using that wrong sampler, which is good. It's actually good. Like I'm not pissed when I'm seeing these messages because they're errors. They're my fail fast assertions that are making it less likely that I'm going to cause a bug in my program that I'm not going to be able to find, right? The best thing that can happen when things go wrong is they go wrong because your code caught it, right? When things go wrong that you're not anticipating, then it makes it easier. It makes it a lot harder to fix, right? Because we can just look at this and be like, fetch 0 or negative sampler value, right? And we can immediately fix that because we have GPU data right here, right? So, so we know that the sampler just needs to be that if it's 0, then it's okay, and it's going to be the same thing as before. So if 0 equals sampler value and strcmp GPU data and pix name and Taudepo. So if those two conditions are true, I did not do that correctly. Hold on, we'll get back to it. So I didn't write that comparison right at all. I didn't even write a comparison. So So 0 and this one is 0 equals this, right? So 0 equals okay, so GPU data pix name. I'd like to keep this space here, but we're running out of room, so well, actually, could we move this over? If we move this over, yeah, we can move that over. That's fine. I'd like this spacing. I think is more important to me than this spacing here. Maybe I'm misguided there, but yeah, I want to make sure I don't go over this column limit, even if that means kind of squeezing things a little bit, making it a little bit inconsistent and ugly. And yeah, so if we are in here, then we need like an OK message, and we see OK. So let's just do OK, OK. Fetched 0 for Taudepo, Samval. So there's no such thing called Taudepo.samval. You know what, I feel like maybe I can write it like this in case one day I'm looking through the code base and I'm trying to find Taudepo.samval and I can't find it, I'm like, what the fuck? Then knowing conceptually that, you know, this is what it is, right? Because the Taudepo, it's inside of the GPU data, so technically it's the Taudepo.samval. So yeah, that's good like that. And then we don't need this extra, we can get rid of that extra space there. And do you wanna... Yeah, I don't... Yeah, we're good. So this is ugly as hell, but, you know, as long as it works, you know, let's not... You know, eventually we'll have, like, a cleanup pass or something, but for now, if it's working, then I'm happy, you know? So, let's give it another run, and it's actually looking pretty promising. So 0 equals... Oh, that's why it was looking easier to write than before. So samval actually needs to be GPU data. GPU data dot samval, right? That's fine. Let's not worry too much about, like, the exact alignment of different lines, or just get a little OCD there. Okay, so no compiler errors. Does the thing actually run, though? Okay, so moment of truth. Let's procrastinate a little bit because we're scared, and now let's press 1 and hope it doesn't crash. Oh my god, it worked! Oh god, yay! Okay, cool. So awesome. So this is pretty awesome. I mean, it's ugly as hell. But this black area, right, we never loaded anything into Taudepo. So, right, because we're going to use Taudepo to kind of, like, store memory. And therefore, we actually want all of those pixels to be black, because right now it's, like, cal-locked memory, right? So everything's black in there. And that's actually what we want, because we're going to use this whole entire memory region to store uniform values. So we have a positive confirmation that that the texture as uniforms, they're in there. They're in the shader. Now the problem you were having is that it was getting optimized out. Like, we had to actually use it to do some texture sampling. Otherwise, the GLSL compiler is smart enough to be like, oh, that variable's not actually used. Well, boop, I'm gonna take it out. So you have to be careful about that. Let's try to, like, go back and forth, right? Like, boop, 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 boop. So, okay, awesome. So we're getting closer to what we need. Let's look at our agenda, because we just did, we just kind of, like, solved part of our agenda. So let's take a look at that. So the agenda screen. Number 8, put uniform sampler Taudepo into Paint 5D frag shader. That was the easy part. We actually did that. Write unit test to check for our math. So okay, we can write that unit test now. And that's a good thing that I wrote this like agenda, because the unit test is like it's tangentially related. Well, not tangentially related. It's pretty related, but it's like it's kind of like in a different thread of thought process, to where if I hadn't written this down, I probably would have like forgotten about it. So let's mark 8 off, and then let's start doing 9. Yeah, okay. So I'm gonna edit this list here, and hold on, that's not the thing I want to list. Edit this properties. What the fuck is going on here? Agenda screen. Everything is locked besides sprint details, so I don't know what's going weird, but now I got it. So I'm gonna take a look at this and edit it. So it's just 8, the uniform sampler, and we kind of just confirmed that it's working, right? So we had to do some like little cleanup stuff to get this working. And so we did some other work that isn't in this list, but we don't want to make this list any longer than it needs to be, so we're just not going to mention what just happened, right? Let's kind of move this up a little bit, try to get some more room here. And yeah, so let's take a look at 9. Write unit test to check our math. Write unit test to check our math is kind of ambiguous. I mean, it has to do with Taudepo, so I know where we're going. In Taudepo dot f, so the function file, right? Okay, so yeah, we got that, and let's take a look at what we need to do now. So I mean, we know what we need to do now, but let's actually go in there. So opening these up, we can actually, well, first of all, let's close everything, right? So let's start a fresh thought process here, and let's go in here. Let's do a git bash here. Git status, git add dot, git commit dash am, texture confirmed, Taudepo. Taudepo? Yeah, is that what? Yeah, sure, that works. Okay. Oh, wait, no, we can't put quotes like that. That's gonna screw with our day. So text name equals, we'll use that as a substitute for quote marks. Okay. And now that once this has like loaded, we'll keep on looking at what we're doing here. Okay, so fresh slate. Let's open up the function file for Taudepo. So lib Taudepo, and we want to look at the function file, right? And you know, while we're looking at the function file, we might as well look up the data file, right? Data file, and oh look, we got these nice diagrams. Fuck yeah! So we can look at these diagrams. That'll actually, if we want to check our math, that might actually be a nice thing to have, right? And so what we can do is, since we have this intermediary CPU side texture that we're using, we can do like these, we can check all our math on the CPU side by using the actual texture, and then we just got to make sure that we wipe it out after we're done with it. So let's see. So in the init, right, we probably want to so right here, let's say that we We can change this around later, but for now we're going to say that, you know, if Taudepo have we ran unit tests yet? So we're going to say, have we ran unit tests yet? And if we have not ran unit tests yet, then we're going to do... oh, that's interesting. So we got to have the unit test in front of this if we're doing that. Yeah, I guess so. Yeah, whatever. I mean, you know, unit tests are usually kind of big. And that's why I'm kind of like, feel like it's one of those days where I'm like, maybe we should have a U file for tests. Or is that just, we're getting, you know, I say that, but then we're going to have everything fractionated in multiple files, and that becomes a pain. And actually having the tests in the same file as the functions actually makes sense, because then we can look in the same file and confirm what's happening in the functions with what's happening in the tests. So let's not do that. However, I think I might make the exception that the unit tests are going to be a forward declaration here. So there's going to be like AAC 2020 Taudepo unit test allowed forward declaration. That's kind of long. We're going to call it AFD, unit test AFD. Which AFD is like, you're never going to remember what that is later, but if you're curious, then you can figure out what that abbreviation means. Otherwise, you can just ignore it. Unit test AFD. What does AFD mean? Don't know. Look it up later, right? So, so we'll just do unit test AFD, and for whatever reason, we're going to keep with a pattern of... So down here at the very end, it's just that unit test can get unit test. The tests can just get really big, right? They can get really, really big, and the chances are, once the code is working, we're not going to want to, like, have to scroll through this shit to look at all the other code. So, in that regard, I do actually want to allow a forward declaration for this. So, U32 AFD, and then it's going to take a U32 called U32. We're going to say if U32, and reserved for future use. Okay. And then return 0x00. Okay. Now we got to define U32 here. Define U32. And then undef it up here. So undef U32. Okay. So with this AFD, we're going to say that, you know, AFD... Well, we have room over here, don't we? So we could just say that, you know... we'll do a little at AFD. And AFD... allow forward declaration. I don't have room to stutter like that, so let's not do that. So that we kind of have this like AFD right above the other AFD, so we can kind of find it. And a little @ symbol to tag it to like what that kind of means. And then in our hashtag documentation, we can put that there as well, right? So AFD, what does AFD stand for? Oh. Okay, so just a little long rant. So basically, I want to avoid forward declarations so that functions must be declared in a very specific order, where the most general functions are actually at the bottom of the file, and the most specific functions are at the top of the file. So all the small details are at the top, all of the larger scope things are at the bottom, right? Because the large scope things depend on a lot of little functions, and the little functions don't depend on anything, broadly speaking, right? There's everything in between, but broadly speaking, little functions have no dependencies. The big functions depend on all the other little functions. And without any forward declarations, you have a guarantee of where you can find certain functions when you are scrolling through like a source file, right? And that just makes it easy to know where everything is going to be. However, with unit tests, because they can be so fucking large, I would rather have the unit test kind of buried all the way at the bottom of the file, so that we only have to look at the unit test when things go wrong. Otherwise, we don't want to look at the unit test. We just want to look at the actual code functionality, and we just want to pretend the unit test doesn't exist, right? We pretend the unit tests don't exist until the unit test breaks, and then we give it some attention, right? So let's and that kind of sounded anti-preventative maintenance, right? Like we don't give the unit test attention until something breaks. But the idea is, like, if you think of what is it? What is it? The Disney book, the Disney. Hold on, Disney management book, Disney management book. So it's weird because I've like read it before. I think it's called like Creating Magic, but I don't know. Let's look it up really quick since I'm kind of ranting. So, Disney management book. I mean, the cover is very recognizable, so I can recognize it from the cover. Creating magic. Yes, it is called creating magic. I was correct. So, Lee Crockerell. I don't know. So I'm just gonna make a note of this. So, creating magic by Lee Cockerell, Disney manager. Okay. So anyway, so he talks about, like, you know, a good manager needs to have do preventative maintenance, right? Like, you don't wait till something goes wrong and then try to fix it. You try to, like, be on top of stuff, and you fix problems before they're problems, right? You look at where problems are going to happen, and you fix them before they become problems, right? Like, you know, like, if you had, like, a car, right, you want to do preventative maintenance, so one day you don't, like, lose your axle on the middle of the highway, which actually did happen to me, so that's a real analogy. Even though I just got it back from the repair shop the day before, so... But maybe a bad analogy when we look at the details. But the idea is they talk about, you know, preventative maintenance, and that totally makes sense. I totally agree with that. And this is more of a business book, but but when you read different books, I think that all the ideas start to interconnect. And so when we're thinking about preventative maintenance, yeah, I did say that we just want to forget about the unit tests until an error pops up. So that's kind of like anti-preventative maintenance. But the idea is that with being a manager of a place like that, you have the power to delegate tasks and have other people do the preventative maintenance. And the unit tests are the things that are doing that preventative maintenance, right? So, right, if you had millions and millions of lines of code, you can't just meticulously preventively maintenance by looking over the code, right? You got to have your unit tests catch it for you. So, if we wanted to use a better analogy that wasn't so pessimistic of wait till things break and then you'll fix them, is that your unit tests make sure that if you do something wrong, you will catch it, right? So your unit tests are going to are your kind of preventative maintenance to make sure that things don't spiral out of control if you make a mistake, right? So if you make a slight mistake, it's just a slap on the wrist instead of everything blowing up and your project becoming a steaming pile of crap, right? So, anyways, so we're going to need a forward declaration for this because we're calling it at a place that it happens down here. So what we could do is I think we could literally put the forward declaration right here, like right above this call. I think that is a valid way to do it. But let's make sure that it actually doesn't compile first. Let's make sure that, oh yeah, I forgot that as well. So, so this flag right here, we'll throw it in here somewhere. So yeah, we already have a MISC section, so let's just do U32. Have we ran unit tests yet? And the answer is no. And then in this code, right, we want to find the bottom of this init function. And at the bottom of the init function, right before we return, we're going to say, have we ran unit tests yet? And the answer will be 1. Yes. Now, a lot of times in some of my old code, I would do lazy initialization, where I didn't want to think about initialization order. So, like, if a function needed another library, if one library needed another library, when one library started up, it would call the initializer to whatever library it needed, right? And the initializers would be like idempotent, and they would know if they had already been initted and needed to be initted again. And now if you do it that way, you need more than one flag. If you're going to do like lazy initialization of all your systems, and you don't want to worry about initialization order, then you have to have a is initted flag, and you also need an initting flag. You need has the system been initialized flag, and also a are we in the process of initializing flag. And you need both of those, because if you don't have an ironclad grasp on your initialization order, and you're just letting every other system initialize every other system, if it requires that system, you will get recursion. You'll get you won't anticipate doing it because your intention is not to do recursion, but as the system is trying to like solve all of its dependencies, sooner or later you're gonna do like a loop somewhere, right? You're gonna try to reinitialize something that is in the middle of being initialized. So you would need 2 flags for that. Now, I'm not going to use 2 flags here. I typically do that. I used to do that in some of my older code bases that were in JavaScript, but we're going to have an ironclad grasp on the initialization order of everything, and to do anything otherwise would be to totally go against the design of this code base. So we only need 1 flag to test if things are initializing. Now, if you lazy initialize systems, because you're like, I don't care about initialization order just as long as things get initialized in the order they need to be, then yeah, you're gonna need 2 flags and you can do it. Now, the reason I advise against that is it's tempting, right? Because once you do that solution, you just need this 1 flag, and it's not much code, and all your initialization problems are solved, right? You just need like 1 extra variable, and all your initialization problems go away. Just 1 extra variable per every class, all your initialization problems completely solved. Except now when you add different systems, every time the program runs, there's the potential for the initialization order to be slightly different. And so you're lacking consistency. As you change the program and slightly modify it, the initialization order could drastically change, right? So I think that it's better to just actually painstakingly figure out the initialization order of your systems. So I know there's like dependency injection and other ways to solve initialization order. I don't know what you call my lazy initialization strategy for that, but maybe just call it lazy initialization, maybe. But yeah, I think it's better just to have a linear initialization of all the systems in a certain area, and know exactly what that order needs to be, right? Because if you don't know the initialization order, then you don't understand your system in the first place, right? So, yeah, that's just my thought on that. So, having done it both ways, this is the way I think is the best way to do it, because we're going to eliminate a lot of uncertainty, right? Because if you do lazy init, yeah, sure, all of your stuff gets initialized, but you have no clue what order everything got initialized in, right? And even if you step through debug to figure out what order things got initialized in, then when you insert a system somewhere or change the dependencies of a certain system, the initialization order for everything will radically change, right? And yeah, so you're just asking for problems if you want things to be that inconsistent every time you compile. All right. What I want consistency. I want enough consistency that, as we build this up, I can add and subtract from the system. Right. I have enough consistency. Consistency, man. Right. So if we go into here, I know I've showed this before, and if you're following along, you already know what it does. But right, we have this consistency where these are all the systems and these are the order the systems are included. This is the order that the systems are initialized in. And if we take this number 21 and we turn it into a 10, then we only compile all of this, right? And it'll still work, right? And if we do 17 here, it's going to compile up to here, and it's all still going to work, right? So you're going to try to layer everything on top of each other like this, and that's going to allow us to do a manual binary search of the code base anytime something really horribly goes wrong, like something really weird, like you're memory stomping something, or you have some weird type of threading issue, or just something really weird is happening that that you just can't that weird things that even tests cannot find, right? Because you just did something completely stupid, right? then this is going to be like our saving grace, right? So, yeah, so have we ran the unit test? Yes. So we flagged that. It should be in only 2 places in here. And let's give that a run. And then once we have this running, well, it's not going to run because we don't have a forward declaration. That is my assumption. If it does run, then I'm going to be like, okay, so implicit function declaration. So that's fine. That's what I expected. So what we're going to do to fix that, a forward declaration, I believe, does not need the word extern. Like, I think a forward declaration for a function maybe doesn't need extern, but all other forward declarations do need externs. Like, variable declarations need externs, but externs are just forward declarations. So, we want to use an extern. I would like to be as explicit as possible, so even though we don't have to denote a forward declaration for a function as a extern, it's going to be... I want the code to be as clear as possible. Okay, so we're going to do extern, and it's going to be, it's going to take a U32, and it also, it's going to return a U32 and take a U32, right? So we're going to do that, and I think, you know, if I very rarely use forward declarations anymore, so I don't know if I'm doing that correctly, but I think if I remember my stuff correctly, then I got this right. Extra outside, 462. So I would say, yeah, that was probably it, because it complained at a different spot. It probably complained all the way down here, right? Yeah, because I keep on doing that. That's just a habit. That's just my habit. I like it when, if the braces are not on the same line, I like to use 2 semicolons, and if the braces are on the same line, I like to use 1 semicolon, except you can't, technically, like, scopes aren't supposed to be terminated by semicolons, so I'm being kind of improper there, and the compiler is catching me, so I'm like, okay, whatever, compiler, you can do it. Okay, yeah, so we're good. So that's working. That was the proper syntax for a forward declaration, and I thought it was, but it's like I very rarely use them, so I'm kind of shocked that that worked. So let's line this up a bit. So that way we can kind of see extern right here, and we see the function twice, right? So if you're not super familiar with C code, it is enough here to like be able to grab onto it, right? AFD allow forward declaration. Sure, why don't we just do that, and then, if that's not enough commentary for anyone to understand this, then they just don't belong in the code base. They need to know a little bit more C, I guess. Now, I don't want to write clever code. I don't want to write code that's like, oh man, you have to be an expert at this language to be able to know what it does. Like, no, fuck that shit. It is nice when you're quickly prototyping something in JavaScript, definitely to be like really terse, because then you can do these nice one-liners. But I don't want to see shit like some var, like this bullshit right here. I wish my boss lectured me about, and a lot of other weird bullshit. Nothing against my boss, but you know, now that I'm not working for him, I'm not going to do shit that way. It's nice to have this terseness so that you can, like, hack something out really quick, but I don't want to hack things out really quick. I want them to be nice and nice, clean, and just built nice and sturdy. And this kind of shit, fuck this. So if you don't know what this is in JavaScript, if you want to cast something to a Boolean, you would not it, right? Turn it to false, and then you turn it back on again, right? So you turn it off again and turn it back on again, right? So if you negate it twice, you get back the original thing, right? And then when my boss is trying to explain this to me, it's like, it's completely obvious, but, you know, I panic, and I'm like, oh god, I can't fucking think when I'm panicking, because I'm being interrogated, so I'm like, oh fuck, I don't know what that means. But it's, you know, very simple. But yeah, you can't think straight when you're panicking. Just pro tip, can't think when you're panicking. And if you can think straight while you're panicking and you do well under stress, then that's cool. I don't know. Okay, so we have this unit test, and we need to kind of like loop through all of the pixels and whatnot. So let's just do for int px equals 0, px is less than or equal to, let's do 512 minus 1, just so I can see the 512 there. And then px plus plus. So we're going to loop through all of the pixels. And then for int py equals 0, and then py is less than or equal to 512 minus 1, and then py plus plus, right? We're just going to loop through every single pixel. Okay. And when we loop through every single pixel, we want to, like, set a value, get a value, right? And that's all we're going to do. And what is that value going to be, right? So, I think for now, we could say, if py is less than or equal to, let's try 512 divided by 4 is 64? I think so. 64 or 128, one of those. Actually, it might be 128. Because 128, 256? Yeah, so it's 128. Okay, so let's say that if py is less than 128, the red... Well, let's look at what our setters are, right? We're going to set values. We're not going to set values. We actually want, like, to test all this out. We're not going to just directly test all the math. We're going to just test the end result, right? This getter and setter, right? Because the getters and setters will use this pixel index stuff. So we're just going to directly test the getters and setters. And, you know, if these getters and setters, these putters, right, if they work, then we're done, right? So... Oh, yeah, that's right. So we actually don't want to... It's not designed the way I'm thinking. This loop is wrong. This loop is all wrong. That's not what we need. So we do need some type of loop, but we want to use these getters. We want to use the get and the put, right? We want to use the get and the put. We don't even want to use pixdex. We just want to use the get and the put. And let's save some space here. So let's do and let's not let's just do v1 and v2 and v3 and v4, right? So get all these values, right? We're not gonna put everything on a single line. Jonathan Blow says if you gotta line everything up like this, then something pejorative. I don't know exactly what he says. I mean, I like the guy. I think he is really smart. But no, I think sometimes lining shit up like that is nice. Other times, you know, you want to prioritize saving space. So I think it makes sense to have these kind of here, and then have these. These can be kind of like sprawled out like that. So we have the get, and then the put is the same exact signature, right? And the whole point of having it as the same exact signature is that I can just paste it, and I can be like put, right? And I don't have to think about it too hard, right? And then I do have to get rid of the little and symbols around here, though, right? Because we're not taking the address anymore. And we're using unsigned integers, 32-bit, for everything. So v1 and V2 and V3. So U32, 32, V2, and I am going to meticulously, even if I'm going to compress the space, I am going to keep on stuttering this, because there's too many weird things, weird mistakes you can make from doing, say, this. Like people might do this, like V1, and then V2, and then V3, and then V4, right? I believe that's the syntax for that. But weird things happen when you have defines and type defs, like hard to find bugs. So fuck that. Why? Why are you gonna do it that way? Like I'm still saving my vertical space here. It's a little bit more clunky, but it's not that much extra typing, right? And the amount of problems I'm going to avoid from just, you know, taking the time to do a few extra keystrokes, just do it, right? Okay, so we have these 4 values, and we can pack up to 4 values. We could also ignore those values. Now, we do want to make sure that these are all set to 0, right? So, we just want to make sure that we don't have any undefined values lurking around. So, V1 equals V2 equals V3 equals V4 equals, and then 0, right? So if I know my code right, that should work. Or maybe that's just JavaScript, but I kind of assume not, because C can also do kind of syntactically strange things. Like maybe you would consider this kind of strange, right? But right, this is just going to float down to, it's just going to go boom, boom this way. So I think that's called left associative. But it's going to go from right to left. So I believe that's called left associative. I don't know my right and left, so terms that need a right and left confuse the hell out of me. Like, I've written a lot of SQL, and I still get right and left join confused, and I will never get it. I just right and left, they're just things that I don't understand. So, like, right and left are things that I don't understand so much that I'll do, like, R0 and L1, so that I know that, oh, 0 is over to the left. Oh, look, I still got it wrong, because 0 is not over to the left. So this variable is wrong. These variables are improper, right? So I looked at the 0, and I'm like, oh, 0 is on the left, right? So L0 is 0 on the left, and then a 1 on the right? So I looked at the zeros, and the zeros and the 1s make sense to me, but the R and the L for right and left make no sense to me. So I'll add numbers to my right and left variables a lot, just because I don't understand right and left. So now that I see L0 and R1, I'm like, oh yeah, L, it's a 0, that's on the left, R is a 1, that's on the right? Because I don't know what the fuck I'm doing. Okay, so we have this getter, and we have these different pieces of memory here. And how are we gonna figure out what this is? And well, we're in Taudepo, right? So it must be some type of Taudepo value, right? So we can look at this stuff here, and we should probably be able to find it, right? And we can't actually see these defines. And I know we put it inside of a struct, right? So we have the defines, but we also have a struct. And and we also have to remove this, right? We kind of pasted this, but we kind of have to change that. We gotta get rid of that if we're gonna. So. Okay, so we know what they're supposed to be. So let's do a let's copy all these. Make some space up here. We'll paste it down here. And we know it's unsigned integer, 32 bits. And we have the defines and everything for them. So inside of AAC 2020 Taudepo, and then dot and paint 5D, or actually no, this would be in Taudepo, right? Well, actually. It's all in Tau 15 here, right? And then in these other things, we gotta like talk about, well, what system are we talking about, right? And like, right, we could be talking about the subsystem, and then the variable slot. So this variable slot actually is just a 0 to 255 value, right? It's just like, you know, 127, whatever. So that doesn't really matter for that, but okay, so this is kind of like how we would set it up. But to make sure that there's no overlap between these subsystems, what we really should do is we should do the gets, we should do the puts, we should do all the puts first, and then we do the gets. Do all the puts first, and then do all the gets. And if we don't do it in that order, like if you do get put, get put, get put, you won't see any mistake. If all of these commands for put the variable at the exact same pixel in the texture memory, and you just do our test as get put, get put, get put like that, you get it, then you get it, you put it, then you check to see that you got it, it is not going to work. It's going to it's going to give you a false positive. It'll always work because it's always putting it in that one spot, right? So we want to check to make sure that we're not accidentally writing memory to the exact same location. Then we're going to need to run all of the puts first, right? So rather than even though we're only going to use this allocation here, so we have these the main allocations of the 512 by 512 are split into 16 sub allocations, denoted by 0 to 15 here. Even though we're only going to use that one allocation, noted by the fact that all these are commented out, we should still test that the whole entire thing works. So, I don't know, example. So we're going to say example here, and we're actually not going to use those. And we're going to do for var tau equals 0, tau is less than or equal to 15, and tau plus plus, right? And then for the subsystem, for var subsystem, is 0 to 15 as well. Sub. And then the variable, right? The variable, I think I'm writing JavaScript again. U32. Yeah, that's fine. U32. U32 var equals 0, right? Because now we can't really use the var keyword if this is JavaScript, but we can call it var here because this is C code. And I'm no longer trying to think about transcribing back and forth between C and JavaScript. Fuck that. Let's just write C code. So with var, var is less than or equal to 255, right? And the range is directly in the variable name here, so that's nice. And var plus plus, right? So if we iterate through all these combinations, we're going to hit every single pixel of the 512 by 512 canvas, right? And we need to do this loop twice. Remember, I said we're going to set everything first, and then we're going to get it, right? To make absolutely sure that we don't have any memory stumps, right? So, okay, and since, so, right, the 2 semicolons is because this, this opening brace ends on a different line than it starts. So that's what I mean when I have 2 like that. And so this is kind of obnoxious, but it's trying to be compatible, right? Because there is no fucking point to taking all these for loops and unnecessarily indenting them, right? There's no need to indent like this, right? Like, why are you going to do that? Like, what the fuck is the point? Like, yes, indenting is good, but do we gain anything from this indenting? No, because look at all this shit. This shit doesn't line up. We cannot see the patterns anymore. We can't see the patterns anymore unless you're actually going to put code in there. don't do it, right? We're not actually going to put code in between these sections, right? So there's no fucking reason you should indent that, okay? I know, like, sometimes you think, yeah, just, no, don't do it, okay? So let's, also declare, so this variable, what, oh, it's the variable value. This is really, oh no, this is the variable index. Right, because this is, it's an index location for the variable. It's where the variable is going to be stored. Okay, yeah. So we're good. So do we want to, where do we want to define that? Do we want to define these, so U32 tau, let's give it some more space than the other stuff, because I actually want to explain what these are. Variable values to set inside Taudepo texture. Okay, so let's give this a little bit. Yeah, let's do it line by line, just so that we can denote what these are. So, so this is so tau. Right, and then so same thing. So all this, right? Which, you know, maybe it's kind of like, you know, redundant. We can already see that in the code here. You know, so maybe it's not like a good idea. I don't know. Loop variables. Okay. So that's good. Okay, yeah, that's good. So, with the putter, we need some way to consistently generate some type of certain set of values for V1, V2, V3. They all need to be between 0 and 255. And yeah, we need some type of generation logic where we can run it, here, and then run it here again, right? So let's say let's keep it dead simple. V1 so the value 1 equals tau plus well, let's keep one of them completely linear. Yeah, so V1 equals tau plus sub plus bar, right? And if we add those all together, does it overlap sometime? Yeah, it kind of does sometimes, doesn't it? But this variable right here already goes between 0 and 255, so the value would already be out of range, right? So we take that, and then we just modulate it by 255, right? So we know we're going to hit all the values. And then V2 is just... how about tau plus sub plus var times... And let's just look up a list of prime numbers. Okay, so list of prime numbers. Oh, interesting. There's a lot of different primes. So we're not gonna get too fancy with our primes. We just want some prime numbers so that, it's more likely that different we want as much variance in, what the values we're kind of injecting in there, and if we use primes, it's gonna be more likely. We could get really fancy with this. We're not going to get super fancy, right? We're just going to be like, so let's take all of this. We're going to add everything, and then we're going to multiply it by a prime, and then we will do modulo on it. So, so 1 isn't considered prime. Why is that? That's a good question. Is 1 prime? What are the rules for prime? What are the rules for primes? What are the rules for prime numbers? A prime number is a number which has just 2 factors, itself and 1. Okay, well, yeah, 1 is divisible by itself, and is it also divisible by 1? Yes. So that is why 1 is not prime. Okay, so list of primes. Hold on, let me look at that. Definition of prime again. Definition of prime. I should, like, know this, but, prime number definition. Okay, well, how the fuck did I find the definition correctly the first time, and then it's like, I can't find it again. History, that annoys me that I can't find. I just searched for it in my history. What is the rule for a prime number? Math basics. Okay, so a prime number is a number which just has 2 factors, itself and 1. Okay. Okay, anyways, let's not worry about that. Let's fuck it. Let's not worry about it. It doesn't matter. It does not matter to what we're trying to do. So let's forget about that. We're gonna multiply by 1. I don't care if it's prime or not. We want to cover. We don't want any gaps at first. Actually, we kind of still have gaps, don't we? Because we're gonna add all of these, aren't we? Well, actually... Oh, no, because this inner loop is going to start first. That's going to go to 0 to 255, so we don't have to worry about gaps. 1, 3, and 7, sure. And V3 equals, and multiplied by 7. Okay, and then we're going to take this, these, we're going to take this line and hope that we wrote that syntactically correct, and we're going to put it right here, right? So instead of using a common function, we're just going to make a little note that it's paired, right? Because I don't feel like writing another function. I mean, we got to, like, the amount of code to write another function for this would be probably as much or more than just cutting and pasting it, right? And yes, that means that if we change this, then we break our tests. But I'd rather be able to directly see exactly what's going on rather than offboard something to a different function. So we're going to do it this way. And the idea is that when we go through here, we get the exact same set of values and we put them, right? Then when we want to retrieve them, we regenerate the same exact values in the same exact way and we get them, right? And when we're getting them, actually, let's keep the V's like this, but let's change these to G's for got. So these are our expected values, and these are our gotten values, right? So over here, let's duplicate all this. Expected and gotten. Quit. And then right here, we'll just change these to G's. G's. These lines don't actually matter, but it's good just initialize things anyways. So I like to, so yeah, maybe I'm just adding random shit that doesn't matter. But anyway, so then our gotten values, we're going to return them, right? And if everything works out, so these are our getters. If G1 not equal to V1, and then or G2 not equal to V2, or, oh, god damn it. And then just paste this two times, right? And then 2 and 3, or 2. Whew, okay, I can't talk. So if any of these things mismatch, then we have failed the unit test, right? So AAC 2020, Taudepo, halt, unit test failed 2020. Okay. And that's all we need. And then we could also have like a OK message over here that notes that the unit test passed. So AAC 2020, Taudepo, and then OK. Unit test passed 2020. Okay, so do I think this test is going to work? I have my doubts. That's the reason why we need this test, right? Because if this test doesn't work, then good fucking luck getting those texture as uniforms to work in your sampler, right? Like, we absolutely, like, even if I think that I check this really carefully, we need the sanity of mind that comes with this test. Also, like I said before, even if we checked all of this code very thoroughly, and we're absolutely sure this code is correct, the unit test is going to help insulate us from accidental changes to the algorithm, right? So let's take this little comment here for paired blocks, and let's just put it here in our little documentation file so that we know what do we know? Marks a place in source code where an identical block of source code should exist. The identical blocks of code in question should be exactly 3 lines of code each for a total of 6 lines, but only 3 unique lines. I'm doing this because writing a common helper function would be more code than just cut plus paste, and would add extra indirection, which would make the code harder to understand. Okay, so there's a reason why we're doing that. We're not completely insane. And, yeah, let's give that a shot. And, do we even have this? Is this a thing? Did we even write that? Because we might have not. Yeah, we probably have. It's probably called info anything kind of thing. It's probably called info any. Info any, right? Because we had way too many logging messages in the other files. Yeah, so we decided to be a little bit more a little bit better here with that. Now, we're only using this in 2 places, so we could just keep it like that. But, you know, why don't we just, we got this section for defines. Let's just do it. So, AAC 2020 Taudepo info any, and define air as AAC 2020 Taudepo halt. Then we can take these and we'll just paste it and then undef them on the bottom. And move that, add a space, change this to undef, remove this space because I don't know how I did that. Okay, and then right here, this is halt, we'll change that to ERR, and then over in the success area, we'll just say INF for info. And because it's an info message, we might want to say that okay. And then since this is an error message, maybe we want to say error inside here. That's a little bit redundant, but we can do that. And then there's no extra info for this, so we'll do a void pointer cast of 0 to be a little bit clear about what's going on there. Okay. Let's give that a run and see what we got. And I'm out of tea. Okay, so I don't know how to rate for loops, it seems. Expected something something before token. And that's line 500. Okay, oh, okay, yeah, I'm seeing it right here. Just forgot to... Really? I just forgot in that spot? Alright, well, yeah, let's make sure these match. Okay, and then we have a putter, and we have a getter, right? Okay, and then also, well, these are V1, V2, right? So, but let's see, make sure they respectively match. So, 1, 2, and 3, and 4. 1, 2, 3, and 4. So those colors all line up correctly. 1, 2, 3. Oh, hold on. I have a whole slot that I'm not using. 1, 2, 3, 4. 1, 2, 3. Yeah. So let's we gotta duplicate this. So now we need a thing that says 4 lines because we fucking screwed that up. So let's change this. Now that we see that mistake we made. What's the next one? 11, I think, is the next prime. Let's look, a list of primes. Hold on. I think 11 is the next prime. 3, 5. Oh, we forgot 5. Well, I like that. I like that. If we use 5, then we don't have to end up in double digits, so we can use 5 and 7 like that. I'm a fan of that. So 1, 2, 3, and 4, 5, and 7. Yeah. So there we go. Let's take this and so this, we'll just make a note. same idea as, but 4 lines instead of 3. Okay, so now that we have, we got that, let's double check that one more time, right? Because we double checked, we found an error. Let's double check another time. I just want to keep on double checking until there's not errors, right? So these colors line up. These colors line up. Do these colors line up? Cyan, orange, yellow. Yep. Okay. Yeah. So all the colors seem to be lined up correctly. Now, also we might want to. But we also made a mistake. So this variable here is just, right now, it's just being set to, so we would have this code wouldn't run right now. So we found another mistake, right? With having these, we're going to accidentally set everything to the same exact location because we're not using these variables here. And then we're going to wonder what the hell went wrong, right? So we could assign them inside the putter, but we want to eliminate any ambiguity. So let's write it as simply as possible. So so really we don't need, really we do not need, we don't need these variables here. We don't need these. It's nice to have these for reference, because they're the actual parameter names. But we just need these. We just need these guys right here. Okay. And we can still keep these variables as reference, right? Because it might be nice to be able to know, like, what does this actually represent? And okay, yeah. So because right, tau, sub, and var, right? So now that we've kind of like found that mistake, let's kind of highlight those, each a respective color, and then also highlight like these the same respective colors, and kind of see if everything there makes sense. So we have these different stripes of color, layered here. So cyan, orange, and yellow, cyan, orange, and yellow, cyan, orange, and yellow. So that now looks to me to be correct. Okay, so now we're gonna give this a run, and yeah, so give this a, we can get rid of this bullshit here where I'm like, that's the way to do it. No, it's not. Okay, yeah, we'll give this a run and see if we can get this running. And then I'm kind of, I don't know, well, I don't want to say, well, what time is it? So we should probably still try to go for 8 hours. But we're getting to like a good checkpoint where unused variable var, u32 var, and it's in for, okay. So I seem to have fucked something up here where, so why is it unused variable var? Because I'm seeing that, oh yeah, so we made the mistake of, right, so the whole point of like declaring them up here was so that we could take out the declaration from the loop. So we were shadowing some variables, which was bad, and the compiler didn't really find that. It kind of found it indirectly, but not in the way I would have liked it to have found it. So, assertion failed. Expression, size of pics equals 1. Enter to exit. So I know exactly what that is. It's on line 206. So this is the reason why I don't like assertions as much as just writing my own stuff, because now I gotta like, I can't just control F for it, I actually just gotta go to the line number. And yeah, that would be kind of important. So why is size of pics not 1 byte? Well, it could be because we're not trying to assert that the entire array is 1 byte. We're trying to assert that one entry within pics is 8 bytes. So what we can do is we're right? Arrays are uniform, so if one element is a certain size, then all the other elements are also the same size, right? So we can just do that, and right, we just want to make sure that there are bytes inside here, because all bets are off if they're not bytes, right? Because we're trying to pack these bytes into unsigned 32-bit integer, right? So let's change that assertion. I'm pretty sure that'll fix the assertion. I don't know if the rest of the code will work, but that'll fix some of the problems, right? And so we have a unit test failed, and yeah, so we failed the test. So that sucks, but it's good to know that that the test has failed, because if we didn't get past this part, then nothing else would ever work, right? So because the test has failed, we are going to have to backtrack a little bit, right? So the idea was, like, if that test works, we're done. We don't have to write any more test code, right? But because the test failed, now we gotta write more test code. So right, so we're just gonna go in for the kill and write this one test to just cover it all and just be fucking done with it, right? But because this test failed, we gotta do more work. So we're gonna take this unit test code that we wrote, and we're going to, up here, we're going to write a new function, and we're going to call it U32 AAC 2020 Taudepo unit test, getter, get put. So we want a unit test get put, and then it's going to take a U32 called U32. And we're gonna throw all that unit test code that we just wrote into there. And we'll still have Taudepo getter get put test fail. Year 2020. Okay, so make a message that tells us that it was this test specifically that failed. And then, you know, we'll still do the, you know, if U32 reserved for future use. And then right down here, for consistency, we will return 0x00. And now we'll take this unit test, and the main unit test function will kind of like call all of the subunit tests. So, right, and now we are ready to give this another shot. It's still going to fail, but we just want to make sure that it compiles, right? We got to make sure that, like, our little refactor was sane, right? And we did that habit that we have for all of our code, because only C doesn't let me do that. So let's put like a dash line I1x64 right there. And since we have more than one function within this scope, it's nice to just kind of like use like a little dashed line to kind of denote that we have that inside this region there's going to be more than one function, right? And they're all highly related functions. That's kind of why we're going to use a dashed line to kind of like not a hard division, but like a soft division, right? Yeah, so let's do we actually change it? Yeah, we got rid of the syntax error. So let's see if we can get this running again. Okay, yeah, so Taudepo get put test fail year 2020. Okay, so we got something. Now, the problem could be that the actual conversion math is wrong. So the getters and putters are both going to use this pick stacks, right? And we're doing all this fancy math, and then we're getting a pixel index back, right? So there's the potential that it's actually the pixel index. So what we would like to do to make sure that that is not the case is as a very simple way to make sure that all the pixel indices are covered, we could just go like we could just try to use every single combination of input, and then if if any, we could pigeonhole it, right? So we could do a loop with pixdex and use every one of these, and then just set a white pixel at that location and just see if that works. But this is the pixel index, so this is not the component index. So we have to remember that as well. So knowing that it's not the component index, right, we could have a problem where when we're converting between components and pixels, we made some type of mistake. So let's do, so the putter relies on the pixel index calculation. So the problem might be in the bit shifting logic, or it could just be in the actual location logic, right? So is the problem with the location of the pixel that we're calculating, or is the problem with the bit shifting and unshifting that we're doing, right? So we gotta figure that out. So we're gonna do, what was the function called? Pixdex. So pixdex, and we'll do 0x00. So we keep that same kind of format, and this is going to come before the get put. It doesn't really matter because they're both already declared by the time we get to here. Since this depends on that, I think it would just make more sense to put it up here, so let's do that. So we know we need this function somehow called in it, and we're going to keep the same signature for everything for consistency. Taudepo unit test and pixdex u32 and then if u32 reserved for future use. All right, reserved for future use. Okay, and then at the end, we're just going to return a, oh, we can't do that, not here. We're going to return 0x00, and then we can add some more dividers between the different code sections. And we obviously need some changes here, so that's weird that, well, I guess the example that's, we cut and paste this, right? We cut and paste the actual head of the function, right? This is the function prototype, I guess is what you would call it, or the function signature. And since we wrote the function signature the way we did, we can just cut paste it, and then we have the call as we need it. So yes, I'm just a cut and paste magician here. Yeah, let's, we just need a loop where, so tau sub and var, right? It's the same thing here. We're doing tau sub and var. So a lot of this code we could keep exactly the same, right? We could just take all of this and, actually, let's take this, right? So let's take these loop variables and, in here, we'll just take them, and are we indented correctly? Yes, we are. Okay, and then tau sub var, and these are these variables. Okay, cool, and then in here we're gonna call it, right? We can get rid of, I mean, it's nice to have this reference, but we're going to use everything. We're going to use even the memory regions that we're not going to use for months and months and months and months from now, maybe even years from now. We're still going to test those memory regions as well. We're going to test all right away. Pixdex, and we can comment this stuff out, right? This is just a reminder for what these parameters actually are. And then we can take tau sub and var, and we're just gonna brute force go through all the permutations, right? Because we're just this is our test code, and we're not really worrying about performance. We're just worrying about, you know, getting this correct. So pixdex. So we actually need a variable called pixdex, right? Because this is what we're testing. I don't know where we want to put it. Do you want to put it closer to the top, closer to the bottom? Doesn't really matter. What is pixdex? Is it a U32? I think it might be a signed integer, like a signed 32-bit. Yeah, it's a signed 32-bit integer. So we will call it I32. I32 pixdex. And I don't think we have I32 here yet, so we're going to do define I32. And we're going to realign some of that so that looks a little bit nicer. And then down here, we're going to duplicate this and then do I32. Okay. So pixdex is the variable we're going to use. Just because it matches the function name, right? So it just makes it easy to see the connection between everything, right? So we call it, the reason why I sacrifice camel case for the function is so that I can highlight this and I can see everything kind of light up correctly. I can connect the dots really easily this way. Now, if I had synesthesia, then I wouldn't need this type of token highlighting. I'd be good. Well, I guess I don't know if people actually control the colors that they see things in. But right, so not autocomplete. Syntax highlighting is just artificial synesthesia, if you think about it. So this, we actually need to set it equal to pixdex, right? So pixdex. And the way we're going to test to see if pixdex is actually hitting all of our slots is we're going to make absolutely sure that all the memory has been wiped. So we'll do like for dex equals 0, dex is less than, dex is less than or equal to 512 times 512 times 4, because that's everything in our memory region, and then dex plus plus, and then we're just going to set every component to 0. And to do that, we actually need the memory region. So, hold on, how the fuck did we... Oh, because it's already wired. It's wired in. This is tightly coupled with that memory region. Okay, got you. I was a little confused for a second. So if it's tightly coupled, then we should see like a CPU pick somewhere in here, and right, yeah. So. Got you. Okay, yeah, so let's take that. Let's take it. And before we try to, like, do some reading and writing to here, let's just make sure that every single slot in here is set to 0 byte, right? So we're looping through every single component, and we're going to set it to a 0 byte, and then we're going to keep on going, right? So, let's call it, we're only gonna, well, actually, we might use it again, so let's actually, let's call it I32, just so that we don't mix it up with tau, var, and sub. Doesn't really matter. Dex, for wiping 5 memory region before use. Okay. So the reason why we have dex, and this is the actual pixel index, I guess we could just reuse pixdex. It actually means that, oh yeah, pixdex. No, we can't. And actually, we're not even going to call this pixdex. We're going to call it comdex. So, pixel index, we are testing. We'll just remove memory region. Yeah, so pixdex is what we're testing, and then comdex. So let me make sure those are correct variables. So pixdex, and then comdex for component dex, right? Yes, those are correct. So, pixdex, comdex, are they both int32s, or did I just fuck that up? Actually, yeah, they're both, pixdex is a, if we look at the signature here, yeah, I32, yeah. So, the component index, why not? Why not just do this little oddity just to make sure we don't accidentally interchange those? And then in our loop right here, right, we're gonna do that. So we're gonna loop through every single component, and then we're gonna set it to 0, right? So erase all Taudepo texture memory on CPU side. Okay. So we're gonna erase all the memory on the CPU side, and we're gonna and then we can work with it, right? So we also want to do this twice. We should really clean up after ourselves just in case, because it could affect the test that comes after. So we want to do that now. So now in here, this pixel index. What we can do is, you know how we had that call twice kind of pattern? We can do the same thing where the first time we set it, right? So we're getting the pixel index, right? So because it's the pixel index, we need to take the pixel index, and we need to multiply it by 4 to get a component index. And we're just going to say equals 1. And we're going to pigeonhole it. We're going to do a pigeonhole where, well, hold on. That might not be right. No, we're not going to pigeonhole it because we should really set a unique value so that, just in case, we're going to try a different methodology for setting that value. We're going to try, like, we're going to do U32, and we're going to com value and a component value, right? And then in com val, com val equals 0. Reset. Okay, we want to reset this before each loop, right? And we're inside the loop here. And then we'll just do like this: com val plus plus, and then or plus plus com. We wanna increment it first, and then apply the operation. So com value plus plus plus, and then modulus 255. Oh, not 255, 256, right? That still wouldn't have affected the code down here. It would still have been in a valid range to where we should have still expected back what we got. But we're just going to take the pixel index, and we're going to set it equal to the component value and modulus 256, so the value is in range. And the component value is a U32, so we can do that. Yeah, that'll be fine. So the pixel dex is times 4 to get a component index, and this will cover every single pixel, right? So then we want to do all of our putters before our getters, because that'll catch like reading and writing to the same exact location. And so this is another kind of like batch test, right? And if this batch test works but the other test doesn't work, then we know the problem is probably in our bit shifting logic and not in the actual location logic here. So here, reset before each loop, and then we should probably make a variable for this called, we're going to call it U32 val 255, because it's in the range 0 to 255, value in range 0 to 255. And we're actually going to make it a U08. We're actually going to make it a byte. And then in here where we're doing this, we're actually going to break it up into more pieces. So we're going to say val 255. And here, we're going to do the modulus like this. And then we'll do a cast, right? So we'll take this, and then on the outside we'll do a U08 cast. And we're still going to keep it as simple as possible, formula-wise. And then we're going to set this, and actually we might have room to where we don't have to... Oh, no, we don't have room. Why did I think we have room? Okay, so let's, I don't know if we want to do this. That looks ugly. You do a 4 in front of it. If you do the 4 in front, we can get everything to line up nicely. Okay, so this is val. Okay, so that's good there. And then we want to make sure that down here, we want to do kind of like the same thing, except we're going to fetch these values, right? So we want to invert this, right? So we're going to take this, and then we're going to put val 255 on the other side, right? And so val 255 equals this here. And if val 255 not equal to then we've failed this unit test. Okay, so we need to make sure that these so put generated value, and then over here we want to get generated value, and then here we'll do it should be like error, and then AAC 2020 Taudepo pix dex test fail. I want to do Taudepo pix dex fail, so I can put the year 2020 at the end, so I know what year this happened. Okay, so that looks good to me. And then set generated value, put rated value let's call it put so we want to put a generated value in each array slot. That's kind of what we're doing here. And let's just try to organize the sections a bit, so we know. Oh, I see what we did here. And then these are the same sections, but it's a get for each thing. So it's the getter side of it. So we want to put everything first, and then we want to get it. Because if we try to do a put and a get at the same time, and we interlace those puts and gets, then we're going to get a false positive, right? The test will say it passes when it totally failed. So we want to make sure that we do it this way. And if you have encapsulation and you're writing Java code, you would never realize that you would need something to do it this way. But if you're low level enough, you realize, oh yeah, actually my test is going to return a false positive if I don't do that. And there's also cases that you might still want to do this even if you're using Java. Java because you don't know what kind of weird abstractions could be going on. So, anyways, that's good. That's I like that. That's good enough. So I'm gonna hope that this doesn't happen, because if this doesn't happen, then all I gotta do is solve the bit shifting logic, and I probably made some stupid bit shifting mistake when I was packing and unpacking values, and that'll be easy. That won't be a problem. So 255, val 255, we're just gonna fetch it from the pixel index multiplied by 4. We want to make absolutely sure that the pixel index is not outside of the bounds, though, right? Because we are testing this code. You never know. So if pixdex is less than 0, or pixdex is greater than or equal to 512, or is and then we'll just do air pixdex OOB site getter section. Right, and then we'll try to take the same exact block of code and we'll put it here as well, right? So, because if we do an out of bounds array access here, then we're gonna be hurting, right? Because we're gonna segfault. I'd rather not segfault. I've gone like a few months without segfaulting because I've been so careful. And I used to like trigger segfaults all the time when I was coding. So I must be getting a little bit better at this footer section. Okay, so we have the footer section, and yeah, this is the footer section. And we might want to actually see how we said this is called this put here. So you might want to do like section put like that, and then call this section get. And the reason why is then we can highlight these and we can see the gets highlight, right? And then when we highlight these, we see the puts highlight, right? Okay, so that's that. I'm pretty satisfied with this as a good like little test to figure out if everything is working correctly. And we're gonna give that a run, and hopefully it works, right? So yeah, let's give it a run, and you know, right, we're probably gonna have to fix some syntax errors. We'll fix the syntax errors. Yeah, we forgot our defines for unsigned integers, so right, because we kind of like just added those in. So all these defines are at the level of the unit test section, so we can just pop on the unsigned 8-bit integer here. So define U08, and then line that up so it looks a little bit nicer, and then we're going to take this line right here, and then at the very bottom we can take this, paste it down there, remove that, change this to undef, add a space. Okay, let's give that another shot, see what other syntax errors we have, and then hope that the test works. Okay, so no syntax errors, so that's cool. And let's see what fails. Okay, so pix dex OOB section put. So that's nice to know, right? Now, actually, the problem there is the bound for the pixel index is not 512, right? The bound is 512 times 512 because we have 512 by 512 pixels. Therefore, this is a false negative. I don't know what we call it, but we gotta change the error checking for that because I just don't know what I'm doing, right? So when you add tests, what you do is you reduce the probability that there are errors in your main code, but the probability that there's errors in your test code are kind of like well, I guess when they kind of like have a dependency on each other, like what just happened, then it kind of reduces the probabilities of errors in both. But I like to think of it as if you add a test, you reduce the probability of errors in your tested code, but you don't reduce the probability of errors in your actual tests. Right? The tested code gets safer, but the test code could still have problems, right? And then if you write tests for your tests, then you just kind of like, you get a who watches the watchers problem. If you add tests for your tests, now your main code is even safer, your test code is even safer, but not as safe as your main code, and then your tests for your tests are in the unsafe, uncertain area, right? The halting problem kind of says that there's no way to confirm the validity of a program, right? So you're always going to have that who watches the watchers problem. Anyways, let's fix this. So we have this out of bound, and it's 512, but we actually want to call it 512 times 512, right? And so God help me if I decide to use a block size of memory that's, you know, not 512 by 512, because we are hard coding ourselves pretty deep into this decision of like everything uses 512 by 512, right? So we're stuck with it. Now the reason why I'm kind of sticking with it is because let's say we had a computer that had like infinite memory, and let's say everybody's computers had infinite memory. And so we're like 512 by 512, why not 1 million by 1 million, right? Well, more data, more problems. These slots of data, they eventually are going to need some type of, they're going to need meaningful data. They're going to need an artist to decide what the values of the pixels are in that data. So the more data I have, the more effort it's going to take for my artist to make awesome art, right? So if we're trying to make an indie game and we're a very small team, we want to design an engine that is going to leverage the fact that we're not that many people, we don't have that many man hours. How can we make an engine really leverage our design choices, right? How can we really leverage things? How can we design an engine that allows a skilled artist to make awesome things with minimal effort, right? So it's not just about that. So you got to think about a holistic approach when you're thinking about this engine design here. Okay, so old compiler error, 512 by 512. So here's the Git section. Let's change this to 512 by 512 as well. Give that a run. And just see what happens, man. Okay, so what do we got? Taudepo git put test fail year 2020. So that sounds like this crazy test right here. Looks like it passed. So let's actually put a message right before the return. I want to get some positive confirmation here. So we're going to take this and we're going to say passed. Right? And we're just going to rerun that. Because I would like some, you know, positive reinforcement here. Forgot about that. So we only have info messages in here. We're getting rid of the we had way too many styles of logging messages in our other files, and it just created this boilerplate bloat in all the files. So we really only want two types of messages. We want an info message and a halting message, right? Is the info message something that's okay? Is it a warning? Those type of considerations have to be decided with what you put in this actual string, right? We don't want that much granularity. We just want to know Do we want feedback that can be silenced? Or is it an error that needs to tell us what's wrong and crash the system, right? So, we're out of room, so for the void pointer, we're just gonna supply a 0, which looks weird as hell. But we don't got enough real estate on the right to be doing a literal void pointer cast of 0. Okay, let's see what we got. Cross finger. Nice! So, the unit test for the Pixdex, it passed. And if we want some more information, let's add some more information just for confirmation, make sure that we're not like insane here. So, we'll do loops put equals 0, and then U32 loops put and got, and then down here we'll just do like a, and then down here we'll just do a and we might not, no, because we have yeah, let's just make sure that the loops put is, if loops put is not equal to loops got. And, the only thing that's kind of weird about this is, if we want to send these off as void pointers, we got to do like well, it's not that we have to do that, but we have to convert it to U64 if we're gonna send it as a void pointer. And for U64, I don't know. I rarely use 64-bit, so we probably don't have... Yeah. Let me make sure it's not like somewhere else. Okay, yeah, so let's solve this right now. So before I get into it, I need a shortcut for U64 and I64. So define U64, U64 define. We'll do define. Well, let's use define U32 for a reference. And then it's going to be U64, right? And then it's uint64 type here. Okay, paste line. And then for define I64, maybe I have that. Nope, I64. I64, define. And for this, we'll take the same thing. Let's just do define I32 for a signed 32-bit integer. And then we'll take the 32 and we'll replace that with a 64, right? And then this int 32 needs to be a 64. So we have the 64s. Do we have 64s everywhere? Yes, we do. Okay, so now what we're going to do is, now that we know that these are correct, we're going to paste these up above here for reference. And then we're going to say paste file. And we're going to create some shortcut files for these, right? So file new. Okay, and it's U64 for that one. So sc files, cxx snip define, and then in here we have, well, that is a thing. Unsigned. So it looks like it's already there. It's like we wrote it, but we never put it in the file. So what the fuck is, I don't know how that happened. But let's go open up those files and see if they are correct, right? Like maybe they're empty, I don't know. Snip, define, do we have, you have U64? Oh, maybe I accidentally created U64 when I didn't mean to. Oh, I see. This looks like it may have been an old one, because it's defined as U64B08. And I know why I would have done that, because I was going to be like, oh, 64 bits, and then we want 8 bytes, right? But, I find that that's just too verbose of a variable name. That's too cluttered. And, you know, we need to normalize the data our programs use, so we also got to normalize the data that our brains use. So, I've decided that bits are what I'm going to use. Like, when I'm thinking about things, I'm going to think about it in terms of the bits. So let's take this, and for this U64, right? U64. And then this one right here, the I64. The I64 doesn't have anything yet. So, file new. And then we can say this as I64 and dot like that. So I64, okay? Okay, so now that we have those defined, we need to have the correct undefs as well. So undef, U64, U64 undef. Okay, and we'll paste a file for that as well. And then undef I64 and I64 undef. And then we'll paste a file for that as well. Okay, and we're getting a little bit, let's kind of like section this off. Okay, and for the undefs, they're really simple, right? It's like not something hard, right? It's just undef, 2 spaces, and then U64. And then in SC files, CXX, snip, and then we have an undef folder. And then we'll do U64 right here. So U64 for unsigned 64-bit. And then we'll make another one for undef, space, I64 for signed 64-bit integer. I64. Okay. So the only difference is the I and the U, so we could just paste and then correct it after we've pasted it. So this is the I64, so we'll put an I here, and we're good. We're done. So let's go back to what we were actually doing. Now those aren't going to work till tomorrow, so we're going to have to actually do it by hand for now. But so here's where we're trying to define that. And we can just do define I think we're doing a U64. Yeah, unsigned. Well, actually, hold on. What was it originally? Was this are we changing sign here? If we're changing signs, we'll just change it to unsigned. Yeah. So no, we're not changing signs. We're good. So so we're gonna do uint 64-t gcc std int.h. Right, because we just want to know where's that coming from, right? And then undef I64. Okay. So let's give that another run, right? And I just want to get a little bit more feedback. I want to make absolutely sure that it's not like passing because I'm lucky, right? Makes pointer from integer without a cast. Okay. So I know what's going on there. I thought that I could implicitly do that, and that it was just the size that mattered, but it looks like I gotta do both. So, where that I64 cast is, or hold on, what the fuck? I64, what did I do I64 and U64? Because I don't know what I'm doing. Init. Oh, I'm doing an I64 here. That shouldn't be an I64 though, right? This should be a U64. Yeah, that's a U64. Boy. Okay, U64. Okay, that still doesn't change the problem. The problem is that after we do that, then we gotta cast it to a void pointer. So we gotta upscale to 64 bits before you can scale it before you can put it into a void pointer, and then we can actually print this generically. So it's kind of ugly and cluttered, but the trade-off is that I only have 2 logging functions if I do it that way. So I like the trade-off. So maybe later I'll decide that nope, I don't like it. For now, that works. So let's see what we get, and so we have data.any, data.any, and it doesn't have any message with it. So I believe that's because... Oh no, it passed, right? It tells us it passed. That the pixdex passed, it failed. The pixel index lookups, those passed. And the loops put was 65536, 65536. So we tested every single possible location that we could, right? So rather than just make up some values and test them, we just brute force tested every single possible combination, and it wasn't as much code as it would to make specific cases, right? Now we could make specific cases where, if we're trying to analyze the problem, we might want to do some specific cases just to be able to analyze what's going wrong. You know, see what we expected to get and what we actually got, like when we're trying to figure out what might be wrong with our formulas. But I'm not going to do that. I'm just going to look at the code and see what we're doing wrong here. So the get put test failed, but the pixel dex, that worked. So that tells me it's either my bit shifting or my conversion to right? So the pixel index needs to be multiplied by 4, right? So there's a possibility that this logic is wrong, right? Or that we didn't consistently use it, right? Okay. So the pixel index should be the location of the first component of the pixel, right? And then I see we're multiplying by 4. That makes sense, because we're stretching the range of numbers from pixels to components. I mean, that looks correct. Hmm. First of all, 0001. Why is this? This is inverted. So, these are the X's, these are the Y's. And so we have, oh. Uh-huh. Okay, got it. Okay, yep, I see. So this code and this code right here, they don't match. They don't match, and which one is incorrect? So we're going to take the original pixel, then we want to take one to the right. Then we want to take the pixel directly beneath by adding 512, the stride, and then we want the kitty corner one, right? Now this is, okay, same pixel, one to the right, and then this is, no, and this is the bottom, and this is the bottom right. So 0, 1, 0. Okay, no, that's the same. It is the same. It's just organized differently. But because these are the x values here, right? And so really, if we have this correct, it should be like that. Now that's not. Now let's make sure that the test still, that the original test with the still passes, but it's the other test that fails, right? So we still get the same stuff where, yeah, we still get the pixdex passing, we get that failing. Okay, so now that's correct now. So after we take the pixel index, right, we just got to multiply by 4 to get the component index. And these component indexes, they look correct. 0, 1, 2, 3, right, to get the R, G, B, and A. And when we're trying to get the value, we have to shift the value, and then we got to mask it with 255, right? And these masks look correct. And then over here, hold on. 24, 16, and 8. 24 and 16 and 8 in the other direction. Yeah. So I'm not really certain about what's going on here. Like, why is that wrong? Like it seems like the bit shifting math is, like, correct, and that we're setting all 4 of those pixels in the spot that we think we're setting them. Now, a problem could happen if we're, like, overlapping, right? So, so we might actually be right, but maybe we are overlapping, right? Are we doing everything correct, right? Is everything modulo 4 here? So, you know, I said that if we do all our puts before we do all our gets, that we'll see problems from, like, stomping memory. So there's the possibility that the areas are kind of, like, overriding each other, because like the component index, the final location for that index, right, we're kind of carving out these 4x4 cells. So I'm going to guess that we're not spacing out the cells. Like when we're looking at how we're, like, dividing up the memory, up here, right at the very end, we want this, like, 2x2 chunk. What I'm going to guess is that our 2x2 chunks are, like, overlapping. So we have, like, a 2x2 chunk here, and then we have another 2x2 chunk here, right? So the index to xy, the index conversion functions are going to work, right? They're going to convert back and forth faithfully, but the math could be off with those index conversion functions. And the way we could test that is we know that since we have 2 pixels, right, it needs to be mod 2, right, because the pixel, the component index we're trying to get is this upper corner here, right? So the component index is that. And we know that we're never going to get the component index of this or this. So we know that, so we know something about the value of this component index and what it should be, right? It should always be an even number first off, and it should always be modulo 2. Yeah, it should always be able to be modulo 2'd and get 0. Also, because it's a component, take 2, multiply by 4, because there's 4 components. Modulo 8 should also work on this as well for when we're looking at the x, and also the y, right, because this is like kitty corner, so the x and the y, modulo 2, modulo 8, they should all work on this. And if those don't work, then it means that we're kind of, like, overlapping somewhere with our calculations. So, so I think that the actual bit shifting logic looks pretty sound to me, and that what's actually happening is we are actually stomping on the memory, right? Because the whole reason we did the putters and then the getters is so that if something happened because of memory stomping, we would be able to see that. So I think we're stomping memory because we're sharing we're sharing identical locations for storing different data, and we need to figure out where that memory stomp is happening. So, so I think that oddly enough, even though it's the test for this that passed, I think this is actually where the problem is. I think that this is where the error is. So we look at pixdex, and so 0, skip 1, so px and py, right? We can do that first. we can add an assert. And we're going to assert that px modulo 2 equals 0. And then we're going to assert that py modulo 2 equals 0. And let's look at how this works. So let's add this. So final, we are trying to return a 2x2 cluster of pixels sliced out from the texture. Thus, the upper left corner pixel should always be evenly divisible by 2 on both axes. Upper left pixel. Okay, right, so we should just be able to assert this, right? And if that assert fails, then we're really honing in on the problem, and our problems will be pretty much solved. Well, not solved, we still gotta analyze what's wrong with the formula, but if that happens, then we're in good standing to figure out what the problem is. So I hope we actually get that assert to fail, but no. So there's a lot of other things. So let's assume that well, hold on. Didn't we, if we had a memory stomp, then, if we had a memory stomp, then the pixdex test would have failed as well, right? Because we have, right, so this pixdex, right, we're still doing the same memory stomp kind of thing. So wouldn't that also fail? Okay, let's try something really stupid. Let's try to change this to a 2. Just sort of sanity check to make sure that we're not, like, getting a false positive and that we actually wrote that test right and it just worked the first time without failing. So let's try to crash that test to make sure that, just as a sanity check here. And, pix dex test fail. Okay, so the dex test failed, and that's, pix dex test fail, right? Yeah, so right here. So yeah, if we, so we do our, we're actually, this is actually working. This test is, it's not like some, I don't think it's some miraculous, like, we somehow, the stars aligned and the test magically is passing in some weird condition. So yeah, I think we're actually passing that. And that kind of brings me back to, I think that the indexed, the bit shifting logic is failing on me. And if it's not the bit shifting logic, maybe, right, we have these identical blocks, maybe we screwed them up, right? So let's make sure that these blocks are identical, because that could be a breakage point really easily. So if we just highlight these, right, they're only going to highlight if they are, they're only going to highlight if they're completely identical tokens. Usually a token, I mean not having space, but in this instance, our tokens have spaces. And yeah, so the formulas here for V1, V2, V4, right? They're all they're good. So G1, G2, G3, G4. So what is G1, G2, G3, G4, right? So let's actually compare what these different values are and see, like, because if we see that the values are, the bytes are just like flipped, like we accidentally packed them and unpacked them in the wrong order, that'll also be quick to fix. So, let's do our information, and we're going to do G1, and actually we're gonna have to do a printf here. Now it's already gonna fail anyways. We're gonna throw an error, so it's not like we gotta worry about that. So G1 and then percent %D, and then V1, right? Because they're supposed to. Those are things that are supposed to be identical. G1 versus G1 and V1. %D, %D, \n, and let's try to like bubble bracket that both of these like that. I don't know, this is getting fancy. And then also we all need those variables, right? So we gotta go G1 and then V1, right? And then we're gonna print off all of those. So because see if we can see what's going on with those values, you know, maybe it's as simple as we packed and unpacked them in the wrong order. That would be pretty nice. Also, maybe when we tried to do our syntax for taking a pointer to the variable, maybe we did that wrong, and it's maybe the gotten values are just, they're always 0, right? Or maybe we're doing something undefined, and every time we run this, we're going to get different values, right? That would also be, that'd all be useful. So let's do a printf and go \n, give us some space to breathe here right before the error message. And yeah, let's just go with that. And is it all G's, V's, G's, and V's? Okay, yeah, so let's give that a shot and see what we got. So there you go. 24, 24, 24, and 0. So the gotten value is 24, but the actual value is 0. Okay. That is actually kind of interesting. Especially that it's 24. This 24 is a shifting value, is it not? And that kind of bothers me. Let's do a let's see how many times it passes. So So else, if this actually doesn't throw, we're gonna say loop pass times plus plus. And I just want to make a record of how many times the loop was successful, right? So I32 loop pass times equals 0, right? And then with this, we can get a, is it failing on the first? Like how many times is it looping before it's like, oh, I give up, right? Is it failing the exact first time, or like where is this failing, right? So let's do a print f and loop pass times and %s \n, and we're out of room. So you know what we're gonna do? We're gonna just be like, fuck that. Define p as printf, and then over here we're gonna do the same thing. So undef. Okay, and then over here we can just remove that. Okay, yeah, sure. That's a little. I would like to keep E as like to keep it lined up. So let's do define E as AAC 2020 Taudepo halt PE. Okay, undef E. Okay. So now let's take a look at that, and let's see if we get something that surprises us. Like, how far is it getting in? Oh, got ya. So I'm getting tired, obviously, because that was a pretty stupid mistake. That needs to be decimal. Okay, so let's see what happens. Does it crash on the first time, or what does it? Loop pass times 0. Okay, so that's interesting, because if it fails on the first loop, then so what we're gonna do is we're gonna do a little smoke test before we try to batch test everything. We should just try to test the very first value, right? Does the very first value work formulaically, or does the very first value kind of fail on us, right? And because this is giving us a sign that maybe the first value fails, but maybe the first value is just overwritten because, you know, we loop through the whole canvas and put values into it, and then we extract all the values. So let's do a little smaller test here. So we have this unit test, and we see that, you know, we're kind of looping through everything, right? Let's do a mini test on one location. Let's do a mini test right here. I don't know what to call it. I'm just going to call it mini test. And because the big test, like looping through everything, is failing, so mini test on one location. And we can take the tau values, and we can just do so we could do v1 equals 1, v2 equals 2, v3 equals 3, and then v4 equals 4, right? We're just going to keep it dead simple. And then for this, right, tau, sub, and var, what we're going to do is we're not even going to worry about what those are, because we're just going to do tau, sub, and var as just all zeros, right? Let's see, can we even get the first slot to work, right? And then we're going to do a get, and our get needs to use different variables than the put, right? So the get uses the g variables, and input uses the viewer. Okay, yeah, so we're going to take this and G1, and let's just kind of duplicate this line, right? Because we're just going to change all these V's to G's, right? And okay, and then we got to change these to G's, and then also we have to put and symbols around, right? We want to take their address, we want to take pointers to them, and let's make sure that's what we're doing in the actual logic here. Yeah, so we're doing and right there. Now, if we weren't doing ands here, then I'd be kind of scared, because that would mean that that the way I decided to use my getters and putters is error prone, and that right, if the mistake was here, that means the mistake is likely to happen even if the unit, even if I fix the unit tests. If I make the mistake in how I call the function, then even if the unit tests are perfect, it doesn't solve my problem, because the problem is in me calling the function wrong, right? So so that's good that that's not the problem. And now I just lost my spot. So, okay, right here. So G's, and then we made sure that we needed the ampersands. Are they ampersands? I think that's what they're called. The address symbols is what we'll call them. And I don't know what key that is because I'm not typing it. So this key, huh? Okay. So let's just insert those where they need to be. And then we'll do a little check, right? So, you know, if V1 not equal to G1, or V2 not equal to G2, or V3 not equal to G3, or finally V4 not equal to G4, then we have some problems. Okay, so let's make sure this is our V, so we're going down the line. And are also going down the line with their G's. Okay, yeah, so that is correct. And not equal. So if that is the case, we're going to do error. And you done fucked up 2020 12 13. Okay. So let's give that a run. And you know, I really kind of hope that this causes the error, because if that is, if the first pixel was somehow incorrect, then we kind of honed in on the problem, right? We want to get feedback, so we want something else. We already have the test down here causing a problem, so we want to kind of hone in on the problem by writing some more tests to get an idea of what's going wrong, right? And you done fucked up 2020 12 13. Okay, awesome. So that means that we can forget about the whole, like, oh, maybe we're memory stomping, and forget about, like, oh, it's the locations. We've done 2 tests. Well, we did this test, then we did the previous test up here, and then we added some more test code. And so we're pretty sure that it's something about that packing and unpacking logic. And we should probably look at what we're actually getting for these values. So let's put a breakpoint right here so that we can go reuse the code we were using for printing this out. Because we already have kind of like it right here, right? So we can just take this exact block, and we can go up here, and we can, right before we crash everything, bring it to a halt, we can, and also we can just do printf. Right before we crash it to a halt, we can take a look at what those are and see if maybe we can diagnose the problem based on just what we're seeing, right? Are we going to see a whole bunch of zeros again? Like, that would tell us that if we see a whole bunch of zeros, then maybe the problem is that we're not using our pass by references correct, or pass by pointers. We're just not, we can't pointer. We don't know how to use pointers. So let's see what happens. Okay, so we have those motherfucking 24s. So I think something is wrong with our bit shifting logic. I think that something where we're like unpacking and packing, we're like, we don't really know what the fuck we're doing, and because we keep on getting 24. 24 is just a really weird number to get. Like, it seems like it's the shift value, right? Because 24 is the shift value, right? So if we actually look for the number 24, right? We look for the number 24 in our code. We're only going to see it in the shifts right here. 24, 24, 24. Oh. I was looking directly at it, and I still was like, I don't know. I don't know. What's the problem? It's right there. It's right... Okay, yeah, well, let's fix it, right? We wrote some tests, right? It's an easy fix. Yep. Yep, it's that, yeah, it's that simple, man. Let's just... and I was thinking that the problem was the bit shifting logic, right? I'm like, I think the problem's the bit shifting logic. Let me look at it. Oh, can't figure it out. Oh, let me write some other tests. Oh, can't figure it out. Oh, let me write one more test. Oh, yep, it's goddamn, it's definitely that bit shifting logic. Okay, let's look at it. Why are we getting 24? Well, let's just Control F and look for the number 24 in our code, and then, oh yeah, that makes sense. Okay, so, yeah, we know what the problem is. Right, so why don't we look at the other one while we're at it, right? So we already made a big fuck up, right? We got, like, we're so careful with the math, and then we get the syntax wrong, you know? It's almost like this diversion thing. So our shifts need to be, when we're using the shift operator, right? We want the amount we're shifting by to always be on the right. It doesn't matter if we're left shifting or right shifting, right? So, yeah, so 0, 1, 2, 3, C2, C3. I know we already kind of meticulously checked these. Like, we already meticulously did this. Like, when I was looking at it, I was, like, making absolutely sure that, like, these, you know, were correct. Like, so I was doing this already. But let's just do it, make sure that all these colors kind of, like, line up, right? And then we know 1, 2, 3, 4, right? So, so if we just kind of, like, take these, we can, like, color code these as well. Because they should all kind of, like... Right, so those, yeah, so the pattern here, that's good. Let's get a run. Let's see if we can get this unit test kind of going, and then, I don't know, I mean, 7 hours. I'd like to get to 8 hours, but we're getting to a milestone, I think. Well, not a milestone, but I feel accomplished. So, so now we're getting a whole bunch of 1s. And it's, you done fucked up on the first try. Let's just call it you done fucked up on the first try, because that's kind of what the theme here is. So are we even doing that correctly? I mean, that actually looks correct. We're kind of mashing them together, because we want to use a bitwise OR to mash things together. So let's take this you done fucked up and say fucked up on the first try, and then 2020 12 13, right? So let's change the error message to that, and then let's give it another shot. So we already changed some of the bit shifting logic, and yet still some of it seems to be wrong. So this is why I have snippets for things like this, because I'm never surprised by how many ways I can screw up bit shifting logic. So the gotten values are all 1, but the values that we put are all 1, 2, 3, and 4. So that kind of tells me that maybe the values are getting truncated somehow before we're, like, pushing them in, right? And so we're like, maybe we're, like, bit masking them with the number 1 for some reason, or we're bit masking them in the wrong range. So let's look at this. So, and 0xff, right? So that should, so the mask was just like an extra step to make sure that it fits within this size here. Oh, wait. Well, you know, it couldn't. It doesn't hurt to this or that. Like, what's the precedence? Because I'm trying to think of it as shift and then or, but I might have my precedence wrong here. So let's look at the operator precedence and see. So we're thinking that shift comes before or, but that might not be correct. So operator or precedent. Oh, there's my problem. I can't spell out precedence, so... Okay, so we're looking for where or and shift are related to each other. So bitwise or, right? And then where's our shift? And so this is the higher precedence up here, right? So it seems to be that the shifts are higher precedence than the ors. So it doesn't look like I'm making a mistake there. Now, even though I don't think I'm making a mistake there, it's good for, like, sanity just to be like, well, we don't know, so let's just, and also index accessors. Right, let's just be really paranoid. Let's say that we don't actually know how operator precedence works, and let's just kind of like do this, right? Let's just go crazy with the grouping, right? And make absolutely sure that the these different things that we're ORing together make sure that the things that we are ORing together are just that's just how it, yeah. Now, I don't think this is going to fix the problem, but it's going to give me some sanity of mind where when I'm trying to think about it and I'm like, is it operator precedence? I'm going to be like, nope, I made absolutely fucking sure that the problem was an operator precedence, you know? So, just in case, right? Just in case, you know, maybe we want to add some more zeros to that. I don't think they would change anything, but, you know, maybe, I don't know. Okay, so let's, give that a look over, right? So let's 24, 16, and 8. Oh wait, are these vowels, do we possibly make these vowels like, you know, some type of like not 32-bit? No. Did we accidentally make the vowels 8-bit anywhere else? Like when we say like did we accidentally use like a... Did we accidentally, so on this first try, are we accidentally using the wrong types here? So nope, so we got unsigned 32 bits, right? And, yeah, I don't know. So let's just give it another run and see what we can, fucked up on the first try. So let's just, you know, so I find it kind of strange that we keep on getting, we're gonna take these again, and we're gonna make another block. So we got all ones, right? So now the question is, well, do we always get all ones? Right? Like, why is that, right? So in order to get a handle on the masking, what we should do is for the values for the So v1 can be 0x ff, right? And we can do this for each of them, right? And because it'd be interesting if some of these values match and then some of them don't, right? Also, another thing I might want to try is, what if we just give it 0, right? What happens when we do that, right? So, but let's try something like this, right? We might get some kind of insight. And this is why I'm talking about how I wanted to keep the unit tests at the bottom, because they were going to get large, right? Let's give these numbers now. Let's give them like little serial numbers. And let's see if that fails. And if it fails, do we still get like that row of ones? What does the failure actually look like, right? Because that could tell us a lot. So the first thing I'm noticing is a negative. So it's trying to print it off, and it's, you know, changing it to negative. That's a problem. 1 is 255, 257 is... So I bet if we look at the bit shifting of this, we're going to see something interesting. Like, if we actually look at... if we actually bit shift these values, we might actually see something. So, calculator, let's open up the calculator and let's start twiddling some bits and see what's up with that, because that actually looks... so let's say we have 1, and what's the difference between 1 and 255? Okay, well, the difference between 1 and 255 is the difference between this and that. So that's actually kind of a big difference, except if we shifted this. No, I don't know. Let's look at 257, right? So 257, that's actually interesting. So where's 257? Oh wait, 257, so it's like... So 257 versus 65280 or whatever. We make all these... Well, that's just 511. So we gotta go pretty high to... Okay, so let's try something else. Let's try... Let's try taking all of this. Let's paste it again. Let's change these serial numbers, 2 and 3. And then, right here, let's do, all F. Let's do, let's try something like, what happens if we just use all F, right? Or actually, let's see what happens when we use all zeros, right? Because if we use all zeros and we can't even get that back, that tells me something, I think. So if we're using all zeros and we can't even pack and unpack that, what is that telling us, right? So let's give that a shot and see what happens there. Failed on the first try, 002. So we're not totally this crazy here, right? We're not that deep in it, but let's take this block and let's copy it again. Let's paste it, and let's try, we'll rename this as 2, we'll rename this as 3, and we'll rename this as 4. So, with 3 here, we're kind of doing this diagonal. We tried all zeros. Let's try all Fs and see if we can kind of garner some type of pattern. FF, 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 and FF. See if we can garner some type of pattern here, right? So let's run that and see how that works. Maybe it still passes because there was some type of transposition error in the packing and unpacking. And so we, failed, nope, so we failed, 002. Okay, so 002. And I'm just missing my closing braces here, 002. Okay, just a little sanity check. Make sure it's happening exactly where I think it's happening. And where's our error message? Where is it? Purple penguins on parade, 002. Okay. So, so we're getting a -1. Are we getting some type of sign extension problem? So what is this? Is this over 32 bits? Hold on, if that's all Fs, then -1, if it's a sign, if we end up with a signed integer, we're gonna end up with a -1, right? So if that's the case, then there's some weird signedness going on here. These are unsigned. Are they really unsigned, though? Is my U32 actually like a... not a U32? Nope, it's unsigned here. And... so this one, right, is telling me that the G's... well, how is it even printing? Well, first of all, let's do printf hex, right? So let's try to do a printf of hex. Printf hex, right? Because we have a printf for hex. So hex value, not a pointer. So we gotta do %0x. So let's actually print it as hex. Right, and we already know that this one's gonna work, so let's go over here. Yes, this one's that is failing, so %0x and %0x, right? So now we want to see what that looks like in hexadecimal, because I think that's gonna give us more insight than just a negative. Now if they actually match, that'll be interesting, like they match, but it's still a failure. So that's actually kind of interesting. So the values we put were all Fs, and we got back this like 10, 10, 10, 10. Well, it's a hexadecimal 10. So that's kind of weird. It's like it's like we are it's like we're missing, like, parts of it got, like, hollowed out, like, So we gotta just look at what 10, 10, 10 is in hexadecimal, so I don't know my hex that well. But I know sometimes people will use, like, when they're trying to create bit masks as a hack, they'll use, like, hexadecimal. So let's just use, hex and 10, 10, 10, 10, 10. So it looks like only one bit made it. Right? We got this like thing, and then there's only one bit like right in the middle, right? Let's look at our bits here. So just here, 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 and here. How does that happen? So once again, I think it's my bit shifting math, but I just don't know what the fuck I'm doing. So, since we do think it's our bit shifting math, what we really should do is we should, we're just trying to split them apart. Yeah, I don't know what's wrong with my math. But it really does seem like it's the bit shifting. Or somehow how I'm like doing the math for that. I don't know. So we're taking every single component, and we are, we gotta shift it into the 0 slot, right? We gotta shift the byte, we got four bytes. We got to shift it over all the way to the right, and then mask it to get the value. And then we just shove it in the slot it needs to be in. So, I mean, that's pretty straightforward. Unless we're like, unless where we're putting it isn't where we're getting it. I guess maybe what we got to do is create like a reusable function here. A getter and a putter for this. I really don't want to put it in its own function. But it looks like if we can't figure it out, we're going to have to. I don't know, let's give it another run for a second. What kind of values are we testing with right now? We're testing with like all zeros and then all Fs? And then we did like this kind of thing. What about, do the values affect each other, right? So we got the 0, 1, 0, 1, 0, 1. Now, if we took this and we copy it, paste it, and we try to do something very similar, but let's color this really quick. So 1, 2, 3. Okay, so you know, we're getting like that kind of pattern. Now, if we make all of these zeros, does that actually change the pattern we're going to observe, right? So if we just set this here, do we get an error there, or do we not get an error? What happens? Does it actually change the value we get back, right? Like, is there some interplay between the values we're packing, right? That would be interesting to know. So let's see what we get. So, so we're still getting the same, for this one, we're still getting the same FFFF kind of thing. So it seems like there's no interplay between the variables, right? So they're not getting like the individual pixels. They're not getting interlaced, right? The pixels aren't getting interlaced, but the components seem to be getting packed and unpacked in the wrong way. So, so let's try to let's just test my understanding of bit packing. So how about we take the, let's actually test our understanding here. And if we create like an array of just 4 unsigned integers, and we try to like mess with them, right? So let's just try to like we're gonna isolate these 2 pieces of logic here, right? And we're gonna try to run them in our understanding. and see if maybe we just don't understand things correctly. So okay, so right here, let's take the code we kind of stole, and we want to pack and unpack, right? So this is going to return the value, so this is what we're doing to pack it in there. And the values that we're trying to pack is just one value, right? So we're going to say that U32 or U32 val 001 equals 0x ff, right? And then we're going to have a U08 pix array, and it's going to store 4 pixels. And this thing that's pix right here, we're just going to call it pix array, right? Now let's actually use a define here. So let's try to keep it as similar to the original code that we were looking at. So let's go define pix and pix array, right? And then undef it over here after we've kind of like tested this out, right? So and then undef pix. Okay, so with this, we got C1, and C1 is just a location, right? So C1 is actually just going to be 0, right? We're going to just test the first location, and that's actually what we're doing here, right? We're just trying to, the locations, everything's zeroed out, right? So, so all those values being 0, yeah, so let's give that a shot. So let's say that, this is a I32 C1, and that equals 0, right? So there's no actual offset happening, but we want to rig it up as close to the code that we're actually running, and our goal is to see that if we'll call this got, right? So we'll call this got 000 or 001, and we'll do like U32 got 001 equals 0 for now, and then like if got 001 is not equal to val 001, then we're just gonna say error. You don't know jack about bit shift, right? So we're just gonna throw an error in there, and then otherwise else info, you know a bit about bit shift. Okay, so let's give that a shot and see if maybe our understanding is wrong, right? Maybe our understanding is completely wrong. And we'll just, even if our understanding is correct, we'll keep this for reference, right? Because it gives us a little sanity of mind. You don't know jack about bit shift. It's official. Don't know jack about bit shift. Okay, so what are we doing wrong? What the fuck are we doing wrong here? So, right, we're taking all those components, and then later we're trying to take those same components and kind of bitwise OR them back together. So, my first thought is, and this I don't think would work, but right, that's still 0. But, you know, we're grasping at straws here, so why don't we just give that a shot? Oh, you know what? I'm thinking that this value is a U32. This pixel value might need to be... this pixel value might actually need to be promoted, to a uint 32 before we shift it. We might actually need a promotion. So if we actually put a promotion in there, U32, promote to U32. Okay, so we just added a promotion here to signed 32-bit. Trying to just get the trying to glue these together in a way where it's like one, two, three, four. 1, 2, 3, 4. Okay, so that's, I'm just trying to glue it together in a way where when I'm looking at it, I'm not like completely like, blah, you know? So if we do that, let's give that a shot. So it might actually need to be, before we shift it over, we might actually need to be doing some promotion, right? Because we're trying to shift, but we're like overflowing. And that would explain some of the weird bit patterns we're getting. So let's give that a shot. And see if we know jack about bit shift. You don't know jack about bit shift. Okay. So is that the same problem here? So we're gonna shift this over, and then we're masking it, and then we're doing a signed integer here. And then this pixel array, right, is the pixel array here, and it's 4 of them. So if got is not equal to val, so got equals... yeah, so I don't know anything about bit shift. Are we... When we shift by... You know, it's a bit shift. We're not shifting by bytes. We're definitely shifting by bits. Well, that's nice, because we thought it was our bit shifting logic, right? We added more tests. We still thought it was the bit shifting logic. Now we're like, oh, let's just isolate this section, right? And see if we actually can understand what we're doing. And we're looking at it, and the answer to that is no. We don't know what we're doing, and I don't know why. So val is a U32. Do I have to cast my do my bit masks need casts? Do my masks need casts? Does this actually need a cast? I don't think that wouldn't make sense. I don't think that would make sense. We don't know what we're doing, so we don't know what we're doing, so we might as well give it a shot, right? We don't think that's the problem. But you've demonstrated that we don't know what we're doing, so we might as well take some guesses, right? Okay, so I don't know Jack. I don't know what I'm doing. It would be interesting to know, well, if Got and Val are not the same, well, what are they, right? What are they? What are the values? Yeah, it would be nice to know what those values are. So, right, we already kind of have this, like, these printf statements, right? So, let's just take one of these and mess with it a bit. So, got %0x \n and got 001, and then printf the value %0x \n and then the val. Okay, so let's give those a shot and see what happens. Okay, I don't know jack about bit shift, and oh hey, look, there's that interesting pattern of 010101 for the got, and the val is FFFFF, right? And that's what we were seeing earlier. So yeah, something about our bit shifting is wrong, right? We just don't know what we're doing, and that's kind of disheartening because, like, if you're trying to, like, say we're trying to, like, do a PNG compressor decompressor, right? And we're trying to do the bit shifting math, and then we can't even do this kind of basic math. Imagine how fucked we're going to be if we're trying to do something like really low level, like PNG compression decompression, right? So so that sucks. But I guess whatever we find here is will be helpful when we try to figure out the problem. So another thought is maybe we're ORing this together. We got these casts before we shift them over. Does this need to be... do we need to U32 this as well? Like, I'm grasping at straws here. I don't really know. But now I'm just, like, guessing. And I'm going to post this on the programmer group on Facebook and get absolutely no fucking answers. Are we shifting in the wrong direction, right? Let's ask ourselves a really basic thing. No, because we're taking out the individual components and we're putting them in there. And then when we take out the components, right, we gotta take them, we gotta shift them into their correct positions. If we shift them... Oh. You think? That's a possibility. This is, this is a 64-bit system. Yeah, but even that, they shouldn't be that large to do that. So on the Facebook group for programming, nobody has any good fucking answers ever. And then when somebody asks like a question and they don't know what they're doing and they post a screenshot, you're gonna get a whole bunch of comments like, "Oh, no code. I'm not gonna give this my time because there's no code." So I think what I need to do is I have to post a screenshot so people will complain that, "Oh, I'm not gonna answer this. There's no actual code." And then the moment they reply with that, I smack them with the code and be like, "Good, I have it on Pastebin. Here it is." Or better yet, I have it on this online IDE. It's ready to go. You can test it, run it right now. Right? You know, here's this executable that can compile. You know, just give them like all the things, right? So if we were to make this into an example that somebody could run, we're gonna have to defined elsewhere, but define for okay, so we're gonna double check. So we're gonna do like define U32 and define I32 and define U08. Right, and if these are defined somehow differently, then we'll get like a redefinition error. Okay. So let's just run that. Like I don't expect any problems, but if we have problems with that, then we're in some serious trouble. So let's just hope that's well, no, it shouldn't be the problem because we already crashed at compile time. Okay. Let's try something. Bit shifting pitfalls C. Who the fuck is this? When should I use unsigned? Never. Okay. 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 Good. Good. So I guess I'm low level, huh? Okay. Yeah, I don't know, man. Oh. God damn it. Really? Is that what I'm doing? Hold on. Fuck! Okay. Back it up. More obvious mistakes. Let me guess. This is gonna work. Let me guess. That's that. Hey, look at that. I know a bit about bit shift. Okay. God damn it. Okay. So, we probably can get rid of, like, this cast, I bet. I bet that's not the problem, right? And we can run this again, right? And we can see if we still know about bit shift. You know a bit about bit shift? Yes, we do. And, yeah, this would help if, like, there were actually, like, a whole bunch of people watching my stream. Like, they could catch these stupid things for me. That would be great. So, up here, it is in the, right, like, every single place right here. One and. Right? And now, we thought there could be other problems, so I'm gonna guess that's the problem, right? I'm gonna guess that everything is gonna work. And that we're just done. Like, everything's gonna pass. Test passed, right? Yeah? Yeah, unit test passed. Pixdex passed, and then I know about bit shift. Okay, unit test passed, 2020. Taudepo info any. Yeah, we're good. Cancel. So now I still have that window kind of stalling on me every once in a while. But yeah, we only like a few hours just to see that we made a really stupid mistake, so... Okay, so we had the unit test, and the unit test is good. We had to write a whole bunch more code than we thought we were going to write, right? We just had to, like, start cut it and paste and cut it and paste, and it got out of hand. And that's kind of why I was like, That's fine. Let's not delete it, right? It's just a whole bunch of extra stuff, and that's why I want to keep it on the bottom, right? Because, right, we just don't want to... When we're looking at all this stuff, we don't want to have to pay attention to the unit test stuff. Like, all this stuff, we don't want to pay attention to that, right? Because it gets really bulky. But we're pretty sane here. Like, we know, okay, all this fancy stuff that we're doing, it's working, right? So that's nice. Now, yeah. So let's git bash here and git status and git add dot and then git commit -am and then Taudepo unit tests passed. Oh, wait, yeah. Git commit -am. Can't put a... Okay. Can't put an exclamation mark in there. Okay, so yeah, that's what we wanted. Now let's look at our agenda. But it's almost 8 hours, and my girlfriend said that at 9 I'm not allowed to work anymore. And it's like it's almost 8, so I should probably start wrapping this up. So let's look at where we are in the agenda. So agenda screen here. Rate unit test to check our math. Do we have that? Yeah, and also confirmed the Taudepo's texture really exists somehow. We actually did that, right? I don't know how I kind of missed that, but we've already kind of confirmed that, right? We have a visual confirmation of that. So now it's all black, right? So there's the potential that it's not correct or whatever, but the thing is we did with the Paint 5D, we kind of put a texture there. And it's like we're reusing the code that Paint 5D uses to get its texture into memory. And so I'm fairly certain that even though we're not returning any colors there, that it does exist. Now, since we do have a little bit of time, why don't we just hack that a bit, right? And use like a pixel fill. Really quick, just to confirm, like get a confirmation, right? So in the init function, let's find that, and there's this should be very similar to the Paint 5D. So we have this like upload texture thing, right? And if we look at the code for Paint 5D's init function, so we'll look at the function for Paint 5D here, and we'll look at the init, and we'll notice that with the init function here, we're gonna see kind of like pretty much the same code except a whole bunch of comments and shit. Because when we copied from here, we kind of cleaned up as we went. But you'll notice that right here we have test pattern, right? So if we take this test pattern, right, which has that checker pattern, right, and we just shove that in there, and just I want to be careful. Remove code line below. Right, so this will totally break everything if we forget about this line. We're gonna break everything. So I just want to make sure that we have a little to-do in there, and we're gonna load a test pattern into the Tau, and we're gonna expect to see a checker pattern where we were originally seeing that black. And if we're not, then we don't have confirmation, right? But if we see it, then we're good. Good, awesome. So, right, we don't see the letters anymore because we're actually sampling from 2 different textures, but they're like perfectly overlaid over each other. So that's why you're not seeing anything, right? So if we actually take out this this thing right here, right? If we take out the test pattern, okay, so if we take out this test pattern and we give it a run, we're gonna see black there again, right? Because now we've kept all the memory in that region to 0, right? And now we see, right? We see the pattern only here, but we don't see it in the background, right? Because in the background we're sampling from Tau, and in the P5D area we're sampling from the Paint 5D memory region. So that tells me, absolutely without a doubt, we're able to get the texture uploaded into the Taudepo slot, and we're also able to get the texture uploaded in the P5D slot, the Paint 5D slot. So that's good. So we have that confirmation without a doubt. Get bash here, get status, git add dot git commit dash am Taudepo texture upload confirmed, right? So we know that's working. And now that we know that's working, we can look at our agenda again, right? So look at the agenda. And so we definitely confirm this. 9 and 10 are definitely done. Now we want to create a tile camera. And we want to know, like, where's that code going? I don't know exactly where that code is going. Paint 5D tile camera keyboard input. So we need this tile camera, like, object. But it doesn't necessarily need to be object, right? It could just be a collection of variables somewhere. So I also kind of think that maybe we just want to keep like a collection of common variables that are like, so we have the Taudepo. So I want to say that maybe we need like vars. So we have a well, actually no, Taudepo is where the is where we're kind of like keeping I mean, we could put the tile camera stuff in Taudepo, but I think that Taudepo is kind of already kind of big. So if we look at our code here, and we look at, let's say Taudepo, oh, it's right here. It's kind of like this nice little list of we got this nice little diagram, we got this list of stuff. Well, actually, no. Hold on. We're already storing the variables here, aren't we? Because we got VPC here. Okay, yeah. So we already have VPC here, right? So we already have the tile cameras ready, right? We just have to add code to manipulate them correctly. We need like a tile camera controller kind of thing, right? A tile camera controller that comes after Taudepo, and we'll look at these kind of values and kind of manipulate them, right? So it takes the collections of pixel values that are going to be stored on that texture, and it'll interpret them as a certain data type and kind of manipulate them appropriately. So let's look at our agenda again. So I want to take this and just edit it really quick. So let's go properties. I'm going to edit this on another screen really quick. That actually has a monospaced font. And our unit test, that is done. Confirm the texture really exists somehow. Done. This needs to be some type of tile cam. It's tile cam 1, 2, 3, 4, 5, 6, 7. To do AAC 2020 tile cam. Okay, yeah, so that looks good. So for the for 11, for item number 11, for creating the tile camera, we're just gonna look at Taudepo's variables, and we just want to create some functions that act on that memory and abstract the memory as a tile camera, right? So we want to take those 4 variables, the lower and upper bounds for the x-axis, the lower and upper bounds for the y-axis, right? And those create our inclusive bounding box for a camera rectangle. And we want to just create some functions that act on those variables and transform those variables, right? And so we just need some type of function library that will do that correctly, right? And this function library is going to be wired directly into, I think it makes sense to just wire it, well, if we wire it directly into tau, we can always decouple it if we need to generically use its functions for something else. But yeah, we need a place where those tile camera functions are going to live, right? Where we can like apply a zoom in and a zoom out to the tile camera. We can apply a move to the right, move to the left, move up, move down to the tile camera. Very simple transformations that aren't really hard, but the code still needs to go somewhere, right? We could do a whole bunch of easy stuff in one file, and that would still become a problem because the code becomes really bloated and we can't find anything, right? So even though it's trivial, it's a unique task that the other libraries have not been designated to do, and we don't want to violate the do one thing and do it well principle. So we definitely want to make another place for the tile camera to go, right? And if we look at our code here, let's look at our chain file, right? Or not our chain file, but the summary of our chain file, of our libchan. So here's Taudepo, and we want Paint5D to be able to mess with the rectangles, right? With the viewport rectangles. So that means that we need to make an insertion between Taudepo and Paint5D. So I'll just make a note here that right here is like a to-do, and tile cam goes right here. So to-do, right? And then we can be really obnoxious and just put that right there, right? So that, when we open this up, we're going to see that eventually be like, oh yeah, tile cam. And when we look at our agenda, on our agenda screen, we'll also see tile cam, so we'll know where we need to go next when we try this out tomorrow. So with that, let's make sure that this runs, right? Because we want to commit it with that to-do note in it so that we know exactly where to pick up, because we've kind of like kept track of we've kept good track of everything, right? So so everything's kind of still working, right? Got everything in the places that it needs to be. So we're going to close this. We're going to Control-C, close that, and then we're going to just do a git bash here, and we're going to commit that, and then we're done. Git status, git commit -am, to do, and tile cam /AAC 2020 tile cam, right? And git status, git push, GitHub. Okay. So next time, right? We have the agenda. So so we have the agenda and whatnot. So yeah, agenda screen. That's what we're gonna do. And actually, so agenda next time. So next time we're still on sprint number 3. But we're on, when we look at what our agenda is, we're on number 11, right? We're on item number 11 of this sprint, right? So, we have the sprint, and it's just like one single goal, one single feature, and then, everything ends up spiraling out of control, right? So these are all basically all these numbers you're seeing is a whole bunch of stuff that I didn't intend to realize that I needed, and it's just going out of hand, right? But that's how code works. There's a whole bunch of unforeseen things, and we're seeing it. Time. It's not break time. To be continued at a later date. So, I'm out of here. Thank you for your time, if anyone is watching. All right.